Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. I hope you've all had a nice weekend. Or, I guess much of the weekend hasn't happened yet, but I hope you all had a nice week. Yeah, I've been doing pretty good. Yeah, last week I actually got like a new monitor, so I've kind of had to redo a lot of my desk setup. Hey Cowie, great to see ya. But anyway, so yeah, if we have a little bit of, I don't know, technical issues, might be because of that, but it seems to all be going fine so far. Oh yeah, let's see. I also had to change my lighting setup. Seems like I've set it a little bit too bright, so let's bring down the contrast a little bit. Anyway, I don't know. I'll fiddle with that some more later. How am I doing up? I'm doing pretty good. I'm ready to get started and maybe finish up this tutorial. Or this section of the tutorial anyway. Oh, okay, I didn't get the correct document open, so let me open that real quick. But how are you doing today, Gowie? Okay, so we want this one. And I think I'll go ahead and open the first tutorial in case I need to refer to it. I'm doing okay, recovering from a late night out yesterday. Oh, okay. Well, I hope you had a good time. Alright, so oh yeah, so last stream we were working on doing baked emission. And I came up, well, I guess I hit upon a really kind of annoying bug. Basically, my shader wasn't baking emission into the light map. And the reason was because in Unity you have to set, I guess the wrong tutorial, yeah. So you have to set this flag on any material that has baked emission. And I had this in the inspector, but the problem was it wasn't being set until I changed the shader and then changed back to the MyLit shader. So yeah, I guess that's just a little thing you've got to do. Yeah, so it was just as simple as going like just picking some random shader and then switching back to the MyLit shader, and then it worked. So you can see the mission here, and if we bake another light map, it should show up. Yeah, it's really simple. I don't know, I guess I didn't waste too long on it. I guess just 15 minutes, but still kind of annoying. But I had a little bit of time to finish up the rest of the section on the meta pass and baked emission. So next up on our list we have subtractive light mode, and in order to support this, all we have to do is add a keyword, I'm pretty sure. But we can see if I switch to subtractive mode, it's not going to look right. So we'll switch there and then bake another light map. Okay, well actually it doesn't look too horrible. Let's see if we can compare it. So this one, it's a little darker. I mean, it's not as bad as I thought. Okay, sorry if you can hear my dog. I'm home alone today, so I might have to go and check on my pets every once in a while, but I think he's just barking at somebody driving down the street. Anyway, so okay. So for mixed light subtractive mode, I think how that worked Yeah, the other week or last week we looked at like all the differences between them. I get them confused, but I think in this mode, basically baked or static objects don't get any lighting from dynamic objects, and yeah, mixed real-time lights are kind of okay, well, let's just go see. I don't want to just give bad information. I can't remember. Lighting modes. Hey NTT, how are you doing today? Great to see you here. Okay, so in subtractive mode, all mixed lights in your scene provide baked, direct, and indirect lighting. Unity bakes shadows cast by static light or game objects into light maps. Oh yeah, that's how it worked. So we can. Sorry, my voice. We can see here this shadow is actually baked into the light map. So this object's static. So if I move it, the shadow doesn't move. That's the main difference. So yeah, if I go back to bake indirect mode, now this object is still static, but if we move it, the shadow moves because shadows are generated dynamically. Okay, so that was the main difference. The shader needs to know a little bit about this because basically that we need to handle shadows a little differently in light probes. I think it's the main thing. If my dog wants to come in my room, you can come in. Come in. So if you see him on my bed. Okay. Let me see. So in addition to the baked shadows, one directional light known as the main directional light provides real-time shadows for dynamic game objects. Okay, so we knew that. Because shadows are baked into light maps, Unity doesn't have information it needs to accurately combine baked and real-time shadows. Instead, Unity provides a real-time shadow color for reducing the contribution of light map to create the illusion of a correct blend. Okay, so that's what I was thinking of. So this object is dynamic. Oh yeah, so it's not even casting shadows? Is that because I guess we don't have the keyword? Yeah, so you can see it's casting the shadow here on the dynamic object, but not on the static object of the ground. So if we switch back to baked and direct, yeah, so then we get the shadows again. Okay, so subtractive light mode is useful on low-end hardware when performance is a concern. You only need one real-time shadow casting light. It doesn't provide particularly realistic lighting effects and is more suitable for stylized aesthetics such as cell shading. Okay, so if I set the main light, oh, that's the camera, to real time. Okay, I still don't get shadows. Let's try adding the keyword to the shader and see if that adds it. I mostly work with the shadow mask mode, so I'm not 100% sure how well this will affect things. Oh, hey Steph, how are you doing? Thanks for coming by. Okay, so shadow. Okay. forget which one of these keywords I need to enable. Probably shadow mixing, I would guess. Oh yeah, because this is for directional light maps. Should I? Actually, now that I think about it, maybe I should do directional light maps first. Oh yeah, so I don't even have that in here. I forgot to add it to the list. Okay, yeah, so let's do that. Because this works fine with, I mean, in the indirect mode that we've been using. Okay, I don't really know. Let's see, so if I add a normal map to this, then we should be able to. So you can't really see anything here, but what this does is basically Unity bakes the light direction of the main contributing light to the light map. And then it uses that direction to kind of do like a diffuse algorithm on the surface when it tries to apply a light map. So you kind of get some occlusion with normal maps. Otherwise, it's just kind of flat, static lighting. I guess you can kind of tell here. So this is let's turn this up to make it really obvious. The intensity, and then I'll bake it again. So even though we have a normal map here, you can see it's not affecting the baked lighting at all. So if I add in the directionality support, it should have an effect. So we'll start with this one. It's after all this. Okay, I don't think, yeah, that's not going to be enough to do it because I don't actually supply any normal information to the light map sampling code. So basically, when I calculate global illumination, I need to pass the normal here. So okay, now I need to turn on directional light maps. Okay, we can kind of see that. Alright. So yeah, the light is really strong, so it's hard to tell at first. But you can see kind of on this in the halo here that the normal map is darkening the light at certain angles. Let's. Okay. I have the. Yeah, this normal strength is clamped to 1, but let's just go ahead and increase it by quite a bit so we can really see the effect. Okay, so yeah, now with the normals very exaggerated, you can see that it does affect the light map. Whereas if I just actually the easiest way would be to have a non-directional light map and then create it again, and you can see it doesn't affect the normal, doesn't affect the actual baked lighting. Okay, so it's a little subtle thing, but it does look or add some detail. Okay, so let's get rid of this. And then in the 2021 version, I need to just copy and paste the changes over there. Okay, and nothing so far, but let's add a normal map to the ground. Okay. And I guess I'll turn this up. Okay, it was still working. I was like, why is it stuck on that black and white? Okay, so again, it's kind of hard to see. Let's just go ahead and test to make sure it's working by increasing the normal strength like I did before. Oh, I did it in the wrong version. I wish this is probably going to happen a lot, but the order of my Unity editors on my Windows taskbar is not the same order as the script, as the Visual Studio windows. So every time I go to switch windows, I have to think about it. So yeah. Okay. Okay, so it is working, and then if I turn off non-directional, then it should, yeah, just look like that. Okay, so we're good. Okay, so let's add a little write-up. So if you have a normal map on your static objects, you might notice that the that baked lighting is not affected by it. Yeah, it would defeat the purpose of baked lighting to okay, well, no, I think I'm gonna get a little ahead of myself. Unity provides a light map mode called directional mode, which allows you to now that I think about it, should probably up here when we first do light maps tell you to set it to non-directional. Okay, I do. Which takes this into account, at least for the strongest light source, strongest baked light source affecting an object. It would defeat the purpose of baked lighting to test this for every light. Okay. To enable it, first add this keyword to your shader feature to your forward lit pass. Now we need to pass the world space normal vector to the sample GI macro. In the second argument, we previously set to 0. Pass the normal to the calculate GI function and then the sample GI macro. All right, Gowie, thanks for coming by for a bit. And thank you for the luck. I think feeling pretty productive today, so I think we'll get a lot done. But yeah, have a great afternoon. Okay. Back in Unity, set the light map mode to directional and bake again. Okay. If you don't notice anything, try artificially increasing the normal strength of your static objects and the baked light's intensity. Switching between non-directional and directional should then produce a visible effect. Okay. All right, so that's all for that. So now again we're at baked subtractive mode. So I'm trying to see if he doesn't have information. One directional light known as the main directional light provides real-time shadows for dynamic. Okay, so can static objects not ever receive real-time shadows? Baked direct lighting using light maps, baked indirect lighting using light maps, baked shadows from static game objects, real-time shadows from dynamic game objects that are lit by the main directional light using the shadow map up to the shadow distance. Okay, that's what I thought. I guess I have to enable that keyword. But yeah, I guess first we should commit these changes so far. Okay, I was gonna say it changed all this, but yeah, it's basically because we lit the light map and changed the lighting settings. Okay, so this is directional light maps. And we'll create a tag. I think it's 15.4. Okay, let's do that. My webcam's looking weird again. Yeah, I wanted to try to use like natural lighting just because I think it looks better when it's behaves, but the problem is it keeps changing and my webcam doesn't know how to deal with it. But Okay. So we've got our tag set up. Okay, so I need to add the shadow map or light map shadow mixing. What, this one? Okay, so if I switch to subtractive light mode. Okay, so now it's got shadows from dynamic objects. Okay, so I think the problem with this mode is that if you, yeah, so the shadows, the real-time shadows combine with the static shadows in a way that's not physical, I guess. Because you can see here they combine correctly because they're all technically cast by the same light. So they shouldn't like combine additively like that. Let's see if I can get it back to where it was. So it has this real-time shadow color. Let's just change it to red. So we can see. Okay, I can see that the shadow color is kind of red tinged here, and that's just so you can try to get them to combine in a better way. I don't really know. No, I'm gonna. This doesn't matter. Let's turn this light down just so it's not so overbearing, because we don't really need it to be so strong at the moment. Yeah, it's hard to. It'll be hard to get it to work correctly. Okay, let's just change it back to something like that. Alright, well, yeah, this is how it's supposed to be. So yeah, you can see the drawbacks to the system, but it is very performant because basically any static object doesn't have a shadow caster pass anymore. Which, you know, can save quite a few draw calls. I guess let's make sure that's true. We enable the frame debugger. Should be able to see the main light shadow. It's kind of hard to tell because things are being batched together. But we can see we have Arlet, Shadowcaster, and then it switches back and forth. Okay, so these are actually rendering different cascades, which is why there's two separate Mylet draw calls. As you can see here, it can't batch with the previous because they're different Shadowcaster shaders, whereas this one can't batch with the previous because it's the first call from a scriptable render loop, and that's because it's a different Shadowcaster or Shadow Cascade. But I guess we could disable batching if we really wanted to look into it, but it's not super imperative. Anyway, so yeah, this was an easy thing. Let's write it up. Okay. Let's implement the other lighting modes. The current, what's it called? Baked and direct. Oh yeah, so baked and direct. The current one is baked and direct. Indirect is the simplest. Okay, did I explain it already? No. So baked and direct is basically just real-time. Our baked lights don't cast shadows. Real-time and mixed lights cast real-time shadows, which all objects receive. Okay, so the real-time lighting, baked and direct lighting. Shadows from dynamic game objects, and then shadows from static game objects. And then static game objects get real-time direct, baked and direct. Real-time shadows from static. Yeah, so this real-time shadows. Okay. Providing real-time shadows to all game objects. Subtractive mode is for lightweight platforms. Subtractive mode is more lightweight, only having real-time shadows for a single light. Actually, that's true. To turn back on the spotlight. So if I'm in subtractive light mode, the spotlight. Oh no, the spotlight still casts shadows. Okay, well those are dynamic. Does it cast shadows on baked objects? Static. It does on this static. Okay, no, it does on this one too. Okay, so I guess if I change it to mix. So I guess the shadow thing is only for baked lighting, so do I have to like generate a new light map or something? Okay, so the subtractive mode only does the lightweight shadows for the main light. Oh, I didn't want to delete that purple light. Okay, that's fine. Baking shadows from static. are breaking shadows from the main light cast by static objects into the light map itself. This way, static materials don't have to render their shadow caster pass in real time. Okay, I think that's good enough. To enable this, we only have to add this shader feature to our forward lit pass. Then in Unity, change the light mode to subtractive. Excuse me. Okay, so bake a new light map. You'll notice right away that shadows blend additively if cast from how do I say this? That shadows cast from static and dynamic game objects blend additively. This is because dynamic objects use the shadow map we're used to. Oh, that's right. While static game objects bake shadows into the light map. So there. Unity has no way to blend them more accurately. To help, you can define a real-time shadow color, which can make the blending at least look better. This is just a feature of subtractive light mode, and you'll have to work around it if you use it. Note that that this only affects shadows cast by the main light. Additional lights cast real-time shadows like normal. Okay. And technically I don't really even have to go into all this because yeah, we're just kind of showing how to implement it, not how all this stuff works, but whatever. Okay, so next we have shadow mask. First, let's commit the changes. Subtract. Looks like 15.5. Oh yeah, and I haven't even tested this in the 2021 version, but okay, well, hopefully it works. I mean, the only change is that keyword, but okay, so let's it's less intense, and then we'll switch to subtractive, generate lighting. Okay, so yeah, this shadow shouldn't move. This one does move, and then they blend weirdly. Okay, and then we can test the shadow color works. Okay. Alright, so now we have shadow mask mode, which is the final lighting mode. And this is the one I'm most used to. But basically how it works is shadows are baked into a shadow mask texture, which is kind of just like static shadows. And they show up only when you zoom out a certain amount, or you just turn on shadow mask mode. So the main drawback to this is dynamic game objects only receive shadows from static game objects through the shadow mask beyond the shadow mask distance. But when you're that far out, it tends to look okay. So to support this, we have to do a little bit to the shaders, because we have to pass in the shadow mask coordinate. Or it's not really a coordinate, it's like just telling the system what shadows are affecting this object. Okay, so the first thing we need to do is enable this keyword. Okay, and then here, and so yeah, we have the shadow mask, and so we just call sample shadow mask on with the static light map UV, so it's pretty simple. I think that's all I have to do. Okay, so nothing happens at first. If I switch to shadow mask mode, okay, so now these have dynamic shadows at the moment, but you can see on the shadow mask debug mode, it's visible. Yeah, so these are static objects, so yeah, they're casting shadows on the shadow mask. So if you zoom out a lot, you can see when that happens, it's switching to using shadow masks to render shadows. So I don't know if you can see on Twitch or YouTube, wherever you're watching, but you can see that the real-time objects aren't casting shadows anymore. So the only two shadows you see are the two from the static game objects, and that's because they're casting from the shadow map. And if I move them, the shadow stays there even though I move the static game object. And if I zoom in, you can see it switches back to using real-time shadows. Okay, and then also in project. Oh, no, this is right. I think it's in graphics. Quality. Okay, yeah, here. So you can switch from distant shadow mask to just only shadow mask, which means you'll use a shadow mask always. Is that right? Okay, yeah, but it still renders shadows for dynamic objects until you get past the shadow distance, and then you can see they're gone. But static game objects only don't cast shadows again, or dynamic shadows anyway. And so if I move to this, where it would be hit by the it should be hit by the shadow from the static object. You can see it doesn't appear. If I turn this back on, yeah, it shows up. So, but unlike the subtractive mode, since the shadow is not really baked into the light map, it's in a different texture. Unity knows that it can blend these two shadows together. Move this back. And then oh, I'm sorry, I had this off screen, but yeah. So you can switch to shadow mask and distant shadow mask mode. Where is... I'm trying to see where the shadow distance is. I forget where you can set that. Okay, let's see. Okay, set shadow distance property. Okay, so it's on the URP asset. It's kind of confusing that they separate these things in different menus. Yeah, so here's the shadow distance. So if I set this down to like 5 or whatever you wanted, at this time I have to zoom in pretty close until I see dynamic shadows. Or if I set this to like 100, I'd have to move really far out. But you can see it does, changing this does affect the cascades. So you don't want it to be too far out, because then basically I'll have lower quality shadows because the cascades get huge. Yeah, I don't know. A lot with shadows is kind of a balancing game, trying to get everything to look right. Okay, so let's test this in the other mode, or in the other version. Okay, so first, put it to shadow mask mode and bake a light map. Okay, and then if I zoom out, see they disappear. Project settings. Set it to shadow mask mode. And yeah, the static shadows don't affect real-time objects. They will when we add light probes, but... And then we can set the shadow map distance, or the shadow distance using the URP settings asset. Okay. Okay, so next we have the shadow mask lighting mode, which is the default in URP. This mode gets around static shadow mixing issue by baking static shadows into their own light map called the shadow mask texture. You can support it pretty easily. First, add another shader feature to your forward lit pass. Then we need to calculate the shadow mask coordinate in the forward lit pass fragment shader and set it in the lighting data structure. We can use URP's sample shadow mask macro, passing the static light map PV. In Unity, switch to shadow mask lighting mode. You'll see baked objects see that static objects still cast dynamic shadows. Zoom out though, and you'll notice that beyond a certain distance, real-time shadows disappear and only static shadows remain. You can tweak this distance in the URP settings asset. Set it to something small to see how URP automatically blends between the two shadow modes. If you want, you can also have static shadows always cast in quality settings. Okay, what do they call it? So the shadow mask mode. Set the shadow mask mode to shadow mask, and you'll see that static game objects only cast static, or I guess baked shadows. The drawback here is that real-time or dynamic Objects cannot receive baked shadows, at least right now. So this might be a good segue into light probes, which we don't do quite yet. When we implement light probes, dynamic game objects can get baked shadows through that system. Before that, though, let's finish up light maps by adding support for dynamic light maps. Okay, so yeah, this is a new feature in 2021.2. Okay, so yeah, we'll go from there. I don't know why my nose always gets stuffed when I'm trying to stream. Let me take care of that real quick and I'll be right back. Alright, sorry about that. Okay, so I need to commit the changes for shadow masks. Okay, so 15.6. Shadow mask. I don't know. I'm not feeling this radio or this station on Pretzel, so let's switch to something else. A little too high energy, I think, for me tonight. Alright. Okay. Alright, so dynamic light maps. We have to add quite a bit for them. I feel like Unity is going to do more with them in the future. For right now, it's hard for me to get like get a lot out of it. But we'll go ahead and add support for it because at some point I feel like, I guess we just want to be future proofed. Oh yeah, and so I have this special keyword. And then go to do this and the vertex function. Basically just calculate the dynamic light map UV the same way that we did. Oh, except yeah, we don't have a nice little macro for it. Okay, no, I was getting confused. I was like, that's fine. Probably we could use this macro with a dynamic light map UV as well. While I think about it, is that? I got most of my code from the lit shader, so I'd assume that's not how how it does it. Oh, yeah. This is actually the vertex function. Yeah, so for some reason they use output light map UV for static, and then they use this for dynamic. Probably, yeah, it probably has to do with shader features actually, and not so much the scaling. But whatever. Okay, and then we need to sample it. Okay, so what I do, yeah, we changed the way calculate GI works. Oh, I forgot. I don't even have... Should I do... Okay, so the problem right now is Unity combines like everything together into a simple calculate GI macro, and I forgot I was just calling sample light map. The reason I'm a little hesitant to do more is because I can't use this macro just yet because I haven't implemented light probes. So maybe I should do, probably just for simplicity, I should do that first before we do dynamic light maps. Well, I guess that actually makes a little bit more sense with the tutorial, because like I said, this kind of segues into light probes. Okay. Okay, so let's remove all that stuff I just did. I guess I really haven't done that much, but... I pretty much just added this, and this, and this. I could just revert, can't I? Yeah, that's probably the simplest way. So, invert. Okay. All right, so to do light probes, did I forget? I don't think there's a shader feature I have to add in. I think it just happens automatically if light map on is not true. You get light probes, basically. Let's take a look to make sure. Have I handled vertex lighting? I think so. I just realized. Yeah, I did actually. It's right there. Okay. False alarm. Collection. Yeah, okay, so there's not a light probe shader feature, which thought I remember that. So what I have to do really is just change this. So first of all, here Unity has like this special, since no object has both light maps and light probes, Unity has this macro that will automatically set the right interpolator for you. This declare light map or SH. And then yeah, SH stands for spherical harmonics, which is it's kind of a fancy term for Unity's light probe system. So we'll do that. And then also here I need to change, just remembered on the tutorial I think I said we have to call sample GI when we do the directional light maps, but we're actually just calling sample light map. Okay, I just wanted to get that out of the way real quick. Okay, yeah, so now our calculate GI function is a little different. But it's actually going to be simpler than this, because it already has the light map. So that other macro is just, or the other hash f was just if we have dynamic light maps or not. And then in the vertex function, instead of just calling output light map, we have to call oh, this is the wrong thing again. Okay, so yeah, we call output spherical harmonics, and Unity is smart enough to only use one or the other depending on what is enabled. What else? Okay, I think that's it, because yeah, we take care of the rest of it in Bake GI. All right. Okay, so light probes, we've got to create a light probe group. They're kind of a pain to work with, but it's just how it is. So basically every point on this group is a light probe, and Unity will kind of store the baked lighting that this point receives, and then the three closest points to a game object are the three that get stored in the spherical harmonics of that game object, and then using the normal vector unity will like kind of try to create like the baked lighting that it should receive. Okay, so you gotta say edit, and then you can click them and move them around. I don't know. I'm not gonna make really complicated light probe, or I'm not gonna make a complicated light probe setup right now. I think I'll just take these and scale them so that they kind of slightly bigger. And then maybe I'll move these baked lights so that they're at the corner of the light probes. Which you can't see both at the same time, unfortunately. And then to test baked shadows, let's just create plane, and doesn't need to be quite so big. It just needs to be on our shadowing these light probes. Okay, set this to static. Okay, so now if I bake this, that's ugly. Okay, so what's causing that? Is it this? Oh. Okay, I think I know what the issue is. It's because this, I shouldn't have used a plane. Like double-sided materials kind of mess up light light mapping. So what you can do is you can create a material. I guess I could go ahead and do that. So what you should do is have this ground material and then select double-sided illumination. Yeah, so you can see it. It looks better now. Okay, so take this object. So when you click on the object, you can see it's kind of showing you all the light probes that are affecting it. So if we move it this way, it starts to get the yellow light from the static light, even though, or the baked light, even though it's a dynamic game object. So the interesting thing though is that because of the way I've done the light probes here, I mean, you'd want to do this better in an actual game, but it's still getting the yellow from it, even though we're really far from the baked light. So if I turned this off and then baked it again, you would see the yellow tint would go away. Okay, well, I probably did, but it's hard to tell because it's one transparent and then also kind of a weird color. Let's see. Let's again make this really strong. Okay, you can see now it's definitely getting that light. And you can see when I move it away, like towards the other probe. Oops. What's going on there? That starts to get less of the yellow as we move this way, and it should get more bluish, but maybe, I mean, I should probably show this with a better material. Okay. Let's set the tint to white and just change this to neutral. Okay, that's much better. Okay, so you can see the yellow here, and then as I move it away, it'll start to get more blue, even though it's still really far from the blue light. And that's just because of the way I've set up the light probes. It just uses the ones that are closest to it. So what you really want to do here is you'd want to have like another set of light probes, or like all around this light, so that it only affects objects when they're close to it. But yeah, this isn't like a level design tutorial, so I just want to make sure they work. The other thing, so like I said, light probes can also get shadow data. So right now it's still affected by real-time shadows, but if we zoom out, it'll be affected only by baked shadows, and if I turn this off, you can see it stays in shadow. And then if I change the quality to shadow mask only, then we can see that even when I turn this off, it still stays in shadow. And that's because the only time dynamic game objects get shadows from static game objects is from light probes. And yeah, it's kind of like a gradient. I wish there was a better way to show this, but all the gizmos make it hard to see. I guess I'll turn that off. Like, there's no hard line where it exits the shadow. Well, actually, there kind of is, because it's transparent. Let's just make it opaque for now. And then, so if I change it back to, oops, distant shadow map, and then turn the plane back on. So now you can see there's a hard line where it exits the shadow. And then if I change this back to shadow mask, it's more of a gradient. That's again because the way I've done the light probe. So what you'd want to do probably is, okay, I have to turn back on gizmos to see it, is you'd want to have like a light probe right at this boundary of the shadow. Which I should probably make a better illustration of that when I actually make the video, but okay. But anyway, so now light probes are working. And yeah, if you look at the actual light probe group, oh, it doesn't show here in this view. So you've got to, okay, so you have to click on the object, and from there you can see the color that's stored in that light probe. So you can see that like these are pretty bright, but also a little bluish because of this light. And then this one's in shadow. And then if you move to these, you can see these are pretty yellowish. But anyway, that's light probes. Pretty easy to implement. Output value vertex. Oh, you know, I'm confused. how could what I just done work? Because I didn't even put sample spherical harmonics. Okay. I did that, but I didn't call this. I did update sample GI. Okay, that's funny. Basically all I just talked about. Okay, well, I mean, we can still kind of see what was going on. Okay, but now it looks a lot more yellow. Okay. So I wasn't sampling the spherical harmonics. So I guess the actual color was kind of all in my head, but my explanation still stands. Okay, that's funny. Okay, so I wasn't actually sampling the color. I guess you could still see it from the light probes, but anyway. But now, yeah, it's a lot more pronounced what's happening. I was thinking that, oh, it's kind of subtle. Yeah, of course it was. Anyway, so yeah, now it's for sure yellow, and then, okay, let's test out the shadow thing one more time. I'm glad I saw that warning. That would have been annoying. Okay, so then, yeah, shadow mask mode. We've got a little bit of shadow here. And then as we move away. Anyway, okay, so I'm just gonna make sure. I really wish Windows would let you rearrange icons on your, or the different bars on your taskbar. Okay, now it's gotten cloudy again, so my webcam's super dark, but I guess we'll just deal with it. I don't really want to edit it on stream. Yeah, I think I'll have to go back to using my artificial lighting system. I guess I'll set it up this afternoon. Anyway, okay, so we've got sample lightmap RSH, then we actually output the SH, and then the only other thing is sample GI. Okay, so yeah, I did get everything correctly. Okay, so now I've got to test all this again here. I don't want to spend too long on this. Light probes. Bring them up above the ground. It's close enough. And then set this up here. Okay, so I'm going to need to give it our ground material again and set this to double-sided global illumination. Wait. Okay, there we go. Didn't catch the first time. And now if I bake it, okay, so it's definitely yellow. Oh, okay, I didn't set this as static. Okay, let's generate this one more time. Okay, there we go. Okay, so that's all working. Let's go ahead and write it. Okay, so light probes can fix that problem and also allow dynamic game objects to receive a little baked lighting. Light probes are points in space which the light mapper calculates. Calculates baked lighting for, contrasted to light maps, which holds baked light information on surfaces. Light probes hold it for the air. Okay, probably say that a little differently, but okay. In your forward lit pass, we need to add an interpolator for the light probe color. Since an object is either static or dynamic, it cannot receive both light maps and light probe lighting. So we can combine them into a single interpolator field. Unity, or rather URP, gives us a handy macro for that. The arguments are the names for the light map and light probe colors, plus the text chord index to use. SH stands for spherical harmonics and is the, I guess, Unity, rather, actually this is Unity. Unity uses to store light probe data. I guess actually pass light probe data to shaders. Let's see. It's not super important to understand how spherical harmonics works. Just know that it needs a normal vector to calculate the correct value. In the vertex function, we can use this macro to calculate it. It's smart enough to only I guess call if light maps are disabled. Okay. Then we should change the calculate GI function to also deal with light probes. URP again provides a nice macro to either grab data from light maps or light probes, depending on which is enabled. Okay, that's all I have to do there. Back in Unity, create a light probe group. You can place them wherever you'd like. Just make sure that there are baked lights near the corners so you can test their effects. Light probes can also hold baked shadow information, so create a static game object to cast shadows on another corner of your light probe constellation. Okay, should I mention about the double-sided GI? I guess so. I should probably have said that up here when we were first baking something. If things look pixelated, you might need to turn on double-sided GI on your materials, particularly if I guess if working with flat planes. Okay, that's fine. Oh yeah, I need to talk about this cutoff. This actually happened when we're doing light or baked shadows. Alright, note that if you're using alpha cutout materials, the light mapper is very picky about certain things when it calculates baked shadows from alpha cutout. First, your shader must be in the alpha test queue, and which we set back in the custom inspector, and your shader must store the alpha cutoff in a property called cutoff. Which we did. Keep this in mind for future shaders. Unfortunately, this means you cannot have procedural cutoffs if you need it to work with baked shadows. Okay. Alright, so bake lighting again. Move around your dynamic objects. Unity will show you which probes affect it and the probe's colors. Turn on shadow mask mode again to test them with baked shadows. Notice that dynamic objects can get shadow or can get baked shadows through probes, but there's no crisp I guess shadow line. It's a good compromise. Okay. Also, I should say let's see, test shadow mask mode again, blah blah. For now, let's stick with distance shadow mask mode. Okay, what else? Alright, I guess I need to commit these changes. Okay, so this was light probes. Okay, so we've got... Okay, so now we're gonna do dynamic light maps. Almost done with baked lights. I knew this was gonna be a big thing, but... Okay, so like I said before, dynamic lights are light maps. I don't really... they don't seem to affect the models very much. So I do wonder if Unity is going to add stuff for them in the future. Okay, so yeah, we're adding the dynamic light map UV. Okay, and then sample GI does change because unfortunately it's again another version thing. So in 2021.2 we have to pass in the dynamic light map, but before that there's no sample GI macro that has 4 arguments, so I think that's all. Oh yes, we need to update the debug display stuff. I forgot about that. But I guess since I haven't done it so far, I'll just do this all at the end. Which makes sense, I guess. Update, debug, display. Okay, so actually, yeah, this is all 2021.2 stuff. So I guess it's probably good that we did everything that both versions can do first. Okay. That's all the baked lighting features for 2020.3. However, 2021.2 has a few more for us. If you're using 2020.3, feel free to skip ahead to the section on the depth pass. But okay, let's actually rearrange this. But for you all using 2021, let's implement dynamic light maps. Okay. So mostly, okay, so I actually can't do that here, obviously, but I'm glad to see that there's no errors. So let's go ahead and copy this to, oh, I'm actually not done yet. Because I've got to add in the dynamic light map shader feature. Oops. Okay. The web webcam is looking really dark now. Let's let me just see if I can fix that real quick. Looking. Alright, I don't want to spend forever on it. It's a little better. I'm sure that it's gonna get sunny again in like a few minutes and then I'll look washed out, but okay. So anyway, back here. Okay, so dynamic light maps, to do it you have to turn on real-time global illumination. So pre-computed real-time global illumination using Enlighten provides diffuse real-time global illumination for static geometry via low-resolution light maps and via light probes for dynamic, and then also global illumination mode that should be used for handling ambient light in the scene. This property is not editable unless both real-time global illumination and baked global illumination are enabled. So yeah, we have both of them enabled, and we'll generate the lighting, and let's see. So basically how this works is it makes direct lights contribute to indirect lighting. So let me see, I'm sure Unity can explain it better than me. So real-time global illumination is useful for lights that change slowly or have a significant impact on the scene, such as the sun. This feature is not intended for special effects or lights that change quickly. To enable it, blah blah. Okay. Yeah, so basically when you turn this on, it makes light probes run in real time as well. So if light also casts shadows, Unity renders both dynamic and static game objects into the scenes or the light's shadow map. Static and game objects sample the shadow map so that these game objects cast real-time shadows onto each other. The shadow distance determines the maximum distance. Okay, so Enlighten real-time global illumination results also have soft shadows. Okay, well, I don't know what does it do because this is just how it works normally. Okay, so yeah, you can see the real-time light map here, and if I turn off the grid, it just kind of has the like, is this directional, or is this the ambient lighting? So I wonder, okay, let's press play and see if we can watch this and get it to change. So if I take the main light, rotate it. Okay, so you can see it is re-rendering, but it doesn't seem to actually, okay, so now it's changing. Okay, so you can kind of see what it's doing. It does just, you know, like ambient light. Okay, so will the spotlight also be added to it? Okay, no, I think it only includes the main light. Or maybe, okay, maybe I had to be like active. So if we generate lighting again. Okay, so the directionality map also, or the dynamic light map also has a directionality map. Okay, so you can see it doesn't seem to be affected by this pink light. So yeah, it's mostly just, oh, actually, wait, I'm not playing, so. But yeah, so it doesn't really. But at least, yeah, we can see it does do something with the sun. So it kind of just, you know, gives some ambient lighting that is maybe a little bit more performant because you don't have to do the lighting calculations for static game objects every second. You only have to do it, I mean, every frame. You only have to do it whenever the light changes, and Unity's smart enough to know. So it is a performance boost in that respect. Okay, and here it's telling me, okay, I'm changing the light too much, so it's like having to do too much work, but... Okay, so that's kind of interesting. Let's go ahead and add that to our tutorial. Okay, these light maps are meant to capture ambient lighting provided by the main light. They can be more performant since more performant than straight real-time lighting for slow moving lights like the sun, since they're only recalculated when the light moves. I guess since lighting is only recalculated when the light moves. Let's see, ambient lighting from real-time lights on static objects. Okay. To implement them, we first need to get the static, or I guess we first need to enable shader feature only in 2021.2. Let's also define a keyword if we're both in a version that has dynamic light maps and dynamic light maps are enabled. Grab the UV from the attributes struct. It's traditionally stored in text core 2 for the third set of UVs. Okay, and then we'll need another interpolator. Interpolators add overhead since the rasterizer has to calculate values for each fragment. So let's only add this one if dynamic light maps are enabled. And the vertex function, calculate the scaled light map UV. And then finally, in the fragment function, we need to modify calculate GI to call a slightly different. Oh, I'm gonna sneeze. Oh, excuse me. We need to call a slightly different version of sample GI if dynamic light maps are present. Just pass the new UVs as well. Okay, so back in Unity, to enable dynamic light maps, turn on, okay, what's it called? Real-time global illumination, real-time environment, lighting, and baked global illumination. Okay. Okay, I'm not gonna remember this. I'm just gonna pass or use my other monitor to help me real quick. So turn on real-time global illumination. Baked global illumination and real-time environment lighting, all in the lighting scene menu. Okay. Then bake lighting once again. It can be difficult to see any changes, so check out the should have left this open a little longer, I guess. Okay, so the real-time light maps. The real-time light maps tab to see the dynamic light map in action. Enter play mode and move and I guess rotate the main light. You can see the light map captures ambient lighting. Okay. So what else do we have? Oh yeah, reflection probes. Oh, 1 second. Oops, sorry, I was muted. Uh, thanks, Mr. Magoo, for following while I was away. But yeah, sorry, one of my cats doesn't like my dog yet, so they were just having some words. But yeah, they're fine right now. Okay. So yeah, so we did light probes, dynamic light maps. So now we're going to do reflection probes. Reflection probes already work, but there's some more like 2021.2 added some extra options to them that we can enable. Okay, so let's see. I think, yeah, we don't even have to change anything to our shaders. We just have to add those keywords. Okay, so dynamic light maps. 15.8 dynamic light maps. All right. Okay, so reflection probes. Basically, they're like a light probe, but they capture like a whole view of the scene, so they can serve reflections to like reflective materials. But in 2021.2, they added a few more features to them. Okay, so let's just add both of the shaders. And probably in the tutorial I might do one at a time, but I don't really think there's a reason to have more, commits for each. Because all we're doing is just adding these keywords. Okay, so let's try blending first. Okay, yeah, so nothing happens here. All right, so let's first, just to make this a little easier on me, I'm going to disable the light probe group and also change this back to 1. Let's turn this real-time light off. In fact, I might just turn off all these lights and turn this thing off too. Let's shadow caster. All right, and so I want to make. So we've got to have some object. Well, I guess we can just use this thing. That we can use to test reflections. I want it to be pretty bright. So I guess this way. Okay, and now let's give it a new material. Normal map. Let's give it the rainbow material. I want to rotate it the other way. Okay, so now if I make a reflection probe. I don't really want it to be in the ground, so let's just like that. I guess I'll make this a bit bigger. Okay. So let's bake this. So it's kind of hard to see because of the light gizmo. I forgot, how do you turn off? Unity changed theirs. Oh, here it is. Okay, so if you turn off gizmos, you can see the light probe has captured the rainbow wall and also the emissive sphere over there. So if I have a material that's highly reflective, so just something with very high metallicity, let's make it smooth. So you can see here it's got the rainbow visible on here because it's a very reflective material. I think if I turn it, yeah, full smooth, you can see. And then if I turned off the reflection probe, yeah, doesn't appear anymore. So that's present even in 2020. Yeah, 2020.3. So the new thing is, well, there's two new things. Let's test. I guess I don't know. It doesn't really matter. I guess box projection is a little bit easier to test because it just needs one. So we'll do that. Okay, so it's got box projection, and so if you turn on box projection, does it? Okay, it doesn't take effect yet. Do I need to bake it again? No. Okay, so what box projection does is it adds like distance to it, because you can see as this moves away from the rainbow sphere or the rainbow wall, it doesn't actually like zoom out, and that's because without box projection, the reflections are static. Okay, so there must be another option somewhere. Maybe it's in settings. Oh, I think it might be one of those hidden settings. Let's look it up real quick. All right, so URP reflection probe box projection. Okay. Normally a reflection cube map is assumed to be at infinite distance, blah, 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 blah. So the box projection option allows you to create a reflection cube map at a finite distance from the probe, thus allowing objects to show differently sized reflections according to their distance from the cube map's walls. Okay, so it's in quality. Nope. Okay, here. So it's in the URP. Or is it in graphics? No. Oh, it's right here. Okay, so I've got to turn on box projection. Okay, and already you can see it shows up really close, and as I move it back, it shrinks. Okay, and the reason it disappeared is because I went outside the bounds of the cube map, our reflection probe, and you can see it kind of looks a little strange. So if I turn off box projection on the cube map, okay, so you can toggle this individually per reflection probe. All right, so let's write this up real quick. Okay, so let's move on from light maps finally, and see some new reflection probe features. Okay, and support some new reflection probe features in 2021.2. Reflection probes basically render a cube map or basically render a 360 to view around them of all static game objects to serve as reflections on highly metallic or highly I guess yeah, metallic materials. Go ahead and create one, as well as a wall, a static. Let's see, a colorful static wall without any changes. Even in 2020.3, you should see reflections on smooth metallic materials. 2021.2 has 2 new features. The first is box projection. To support this, first add a shader feature to your forward lit path, then enable box projections both on your URP settings object and the reflection probe. This makes reflections shrink as the mirror moves away from the bounds of the reflection probe. The second new feature is probe blending. This is also enabled simply with a shader feature. Turn this on in the URP settings asset and create a second reflection probe. Okay. Yeah, I need just say the bake lighting. Okay. Second reflection probe and bake lighting. You should see reflections blend between the probes as you move a reflective object back and forth. Okay, so make another reflection probe. I don't know if I need to have something else to test it with, but yeah, you can see it switches. Basically, when I'm on this side, I get the reflection of this emissive sphere, but when I cross the boundary, I don't get that anymore. Well, actually, I get it on the other side. Yeah. Okay. And then to turn on blending, I have to go onto the settings asset. Oh. Turn that on, and then I also need to enable that keyword. Okay, so right now I'm kind of in the center, and now you can see basically this object appears on both sides of the reflection, which is kind of strange, but and as I move farther away, it actually gets stronger. Again, basically how good this looks depends on how much you actually want to place reflection probes around your scene. But anyway, I just wanted to test that it works. But you can see now we don't get like that sharp jump anymore. It does blend between them, which is mostly what we wanted. And then if we turn it off, it'll just jump between them. Okay, so that was pretty simple. Okay, I don't really think I need to talk more about that. Okay, let's just say these features add a lot of realism without complicating their shader. Okay, so I think we have one more thing. Oh, okay, so now we have some more debugging. Okay, so we've added a lot to the shader. Let's update our debug visualizations to see some of these new lighting sources. In your forward lit pass, set the light map UV dynamic light map UV and spherical harmonics depending on which is enabled. I guess, yeah, I'm kind of getting ahead of myself. I should commit these changes. So this is reflection probes. Okay, 15.9. Ooh, I'm gonna have to mess up my sorting again. 9 reflect. Okay. Did I don't know. I'm a little worried I set the tag to the wrong head, but I can fix that later if I did, because I guess I still have all the commits ready. Anyway. Okay, so what I need to do is, again, nothing really in 2020, but I'm kind of using this as the base, so I'll make my edits here first. So basically all I have to do is here add the new stuff for the light maps. Okay, so these views should now be available in the rendering debugger. Okay, so that was pretty simple. Okay, well, yeah, basically it says no. Okay, so lighting complexity still doesn't work. I'm a little surprised by that. What does it need? Because it does work in the research, right? Yeah. So what am I... But now I pass everything, so I will... Oh, it must need this screen space UV. I'm just gonna set this real quick because I'm curious. Yeah, I haven't added this in yet because you don't really need it until you add screen space ambient occlusion. Oh, of course I put it on the wrong version. Okay, yeah, that was what it needed because it has to draw this text overlay. Okay, well, it's not like we really need that at the moment, but... Okay, so does it not? I thought it would show something Like, why do I even have to pass the light map UV and stuff? Because it doesn't do anything with it. Yeah, there's not a version. Yeah, you can just see the global illumination. Maybe. So we have reflections. Which is nice, but okay, so nothing actually uses that stuff. Well, that's kind of annoying. But okay, I guess we've got it there for whatever. Okay. This unfortunately doesn't seem to enable any more debug views, but at least it's future proof. What we can do is take advantage of some cool views from the meta pass. Okay. So basically there's all this, there's a lot of like visualization that we can get from the meta pass, and this lets us get some more debug views in another. I don't know why Unity didn't combine these together, but there's a different window that you can go to get through this, or you can go to get this stuff. Okay, so yeah, we have a keyword, and then if it's enabled, we have to pass a couple more interpolators. And then in the vertex function, we just call this special function to, I don't know, do some kind of magic. Actually, I haven't even looked, but it just enables a debug view, so that's good enough for me. And then got to just pass these values down to the meta input. Okay. All right, let's look and see what that does. So it's not in here, it's in here, I think. So I've got systems view, clustering. Okay, so I think when I was looking at the real-time light maps, it like calculates the real-time lights and like in these tiles, which I think that's what this is showing. So lit clustering, UVs. Maybe this is light map UVs. I'm not exactly sure. Okay, and then this shows objects that, so yellow doesn't contribute GI, but it receives light probes. Blue contributes global illumination, either from emission or whatever, and receives light maps. We don't have any, but red would contribute and then receive light probes. Okay. And then we can see the albedo from the real-time GI, which doesn't have any. Neither does it have emission, but then it does have this indirect lighting. So you can see there's a little shadow around these and then a shadow from that crease. This will also change when if we rotate the sun. Yeah, we can see it's recalculating. And then the directionality. And then for baked light maps, so this is kind of nice. We can see the baked GI. So yeah, we can see here there's a lot from this emissive. But even here, even though this texture is not emissive, some of the light still bounces off of it. And that's another thing that's enabled by the meta pass. Yeah, so then directionality. So here you can see it's not completely from the sun because it picks the object that's closest to the surface. So here it starts to point towards or it picks the object that has the strongest light close at this point in the surface. So here it is pointing towards that emissive sphere. Shadow mask. Okay, and then albedo. Emission. You can see kind of the weird pixelation here, and I guess that's because the meta pass doesn't run any more high resolution than that. Okay, we got some UVs again. Texel validity. Maybe this is like, I don't know, actually I need to go read up on that probably. I don't want to just guess. Okay, so UV overlap, this is seeing if like some light map UVs overlap, which can look bad. Okay, so it's seeing if anything gets cold. And then light map indices, so if you have a lot of static objects, it will bake light maps into multiple textures, and so this will tell you what index. And then like, okay, so this doesn't actually work. Light overlap. So this happens like if you have more than, I think, 4 lights on a shadow mask, some of those lights will have to be disabled because you can only have, there's only 4 channels in a texture, so you can only have 4 shadow masks. But anyway, there we go. This will let us see our split up static and dynamic light maps in the scene. This will let us, I guess, view as well as directionality, albedo, and albedo and emission from the meta pass. First, define a keyword. Oh wait, now that did I do something? Because I just realized I didn't add the editor visualization to our meta pass, but it still seemed to work. Okay. Okay. Let's see. So what does the editor visualization actually do? Subscript. Oh, I didn't add dynamic light maps to the meta pass, did I? Okay, that's Okay, that's a shame, but I guess we'll have to... Can't really roll back my project, so I guess we'll just add this in here, and I'll have to remember to copy and paste it. Okay, I mean, really the only difference is I have to get the dynamic light map and then pass it to these functions, so it's not that big of a deal. How do I want to... Well, let's see. So what have I done? So I just did reflection probes, right? Because I could roll back a little bit. Because the reflection probes, basically the only thing is those keywords. So I haven't done that much, I guess. Okay. Well, this will be a little messy. I don't think I'm gonna roll back. I'll just have to remember to get the meta pass from this future commit. Okay, I know that's like, it doesn't have anything to do with the tutorial. It's just me thinking about how I'm gonna keep things clean. What do I? Okay, let's see. So these changes would only go to the meta pass. I guess this is fine. This is kind of annoying. Let's write a note. Okay, so yeah, I guess I've got to write this in here. We should also slightly update the meta pass. Just get the dynamic light map UV from the attributes struct and pass it to the correct okay, so either meta vertex position or unity meta vertex position. I guess even in 2020.3, this function had dynamic light map support. Remember to also include the tiling constant in this version. Okay, that's fine. I mean, I'm a little annoyed because my commits are going to be slightly out of sync, but it's really not that big of a deal because stuff... It only has changed the meta pass, so basically I need to grab this. And then this. Oh yeah, and I also pass this to meta vertex, not unity meta, so okay, and then copy this over to the lit meta pass. glad I caught that. So that should update this. But the funny thing is, all this still worked even without that. Maybe this gives it better data. I'm not entirely sure what that editor visualizations does, but Unity has it in their lit shader, so I want to as well. You know, maybe what happens is Unity just kind of replaces everything with their default lit shader when it's in these visualizations, and that's why it still works. That's probably it, but just in case that changes, I don't mind having support for it. It's not like it really messes up anything. Anyway. Or it's that complicated to add. First, you might not even have to change any code to see these visualizations, but just to be sure, let's add support. What's the term? Add I guess implicitly or explicitly. Okay. In your shader file meta pass, add a shader feature for visualizations. These are in a different location than the previous debugger. Then in the meta pass, add a couple interpolator fields and fill them in the vertex function using this function from URP. Then in the fragment function, let's see, we would just if oh yeah, so first we gotta define a keyword if we're in 2021.2 and visualizations are enabled. Let's see, add a couple interpolator fields, blah, blah. Then in the fragment function, pass these visualizations to the meta input structure. Oop. I keep on pressing Control-Shift-Save. Don't really have to do that in Google Docs. Okay, so check these out in your scene and be sure to refer to them if you ever see any strange baked lighting. Okay, I think we're finally done with baked lights. I really didn't think this would take so long, but I guess I shouldn't be too surprised because, yeah, there's a lot to write out. Okay, so let's commit this. So This is visualization and meta pass dynamic light maps. Since I messed that up, but it's not that big a deal. It will be fine. Okay, so 15, 10. I'm just gonna call it final. I guess I should make sure there's no bugs. So, visualizations and dynamic light maps and meta pass. Okay. Alright, so I have 5 more minutes, or 10 more minutes. I might actually be able to do the next part. So, we're going to do the depth pass. I think we'll be able to finish it, but it might take me a little bit longer to write up about it, but it's pretty simple. Yeah, so basically we just create a new pass. This is for creating a depth texture, and then we need this for screen space shadows, so we'll also show how to do that. Okay. So I guess first of all we need to create a depth only pass, and I think I can pretty much just copy this over because I don't think this pass ever changes once we create it. Okay, so this will be my lit depth only pass HLSL. And we'll go ahead and copy it. And I'll just delete this data because I don't need it for the tutorial. Okay, and pretty much what this does, it just outputs, well, it never outputs a color because we really only care, oh, I guess it does change actually because we're not doing any instancing yet. So yeah, let's get rid of instancing. Okay, I guess I'll have to come back for that. Okay, but yeah, basically what we do is if it reaches the fragment function, then the renderer will store depth. But then like if we have alpha cutout, it will see that it has to do this calculation, so. And then in the shader file, I just need to add a new pass. Yeah, no instancing. Okay, I think that's it. Okay, so I can test this by how I usually do it is I'll turn on hey Ipgal. Oh, I'm not. I've done lots of stuff with the shader graph. My patrons actually asked me not to do shader graph, so that's why I'm doing this tutorial. But thanks for coming by. Okay, so what I would normally do is I would use screen space, ambient occlusion, and then turn it to depth only to test this, because that will cause this to show up. But I don't really want to talk about the screen space ambient occlusion yet because I don't have a support arc, because our shader doesn't actually use it. But I can see now we have this depth pass. It's really hard to see depth in the frame debugger because a lot of times it's just all so dark. Let's turn this off. If I move the camera really close to something. Okay, so now it kind of shows up. I don't know if you can see that very well. But anyway. So that's one way to do it. I guess I could just do screen space shadows, but the thing is people don't have it in 2020.3. Okay, so let's find. Is there something simple that requires a depth pass? Maybe. I bet post-processing will. So let's create a new global volume. And just a new post-processing. Okay, where did it save that to? Okay, that's fine. Forget. I know depth of field will look for sure. So just turn this on to Gaussian. Okay, well, I shouldn't have to mess any of these up, actually. Oh, it's not showing up yet because I need to turn on post-processing in the camera. Okay. Okay, so this isn't actually not drawing the depth pass. It's copying depth from the depth buffer. So no, this won't do it, unfortunately. Yeah, no. Let's see, so URP depth only pass. Maybe this will show up. Okay, that's what I knew. Okay, well, I guess it's kind of annoying because I don't know an easy way to turn this on besides writing my own shader feature that requests it. Maybe that's what we'll have to do because I want something. Well, I guess I could just do the screen space ambient occlusion. Okay, I guess we'll just implement screen space ambient occlusion here. I guess that works, yeah. And then we'll do the same for depth normal. Okay. So depth only, pass, and screen space ambient occlusion. Oops. Okay. Anyway, you know, gotta go get some lunch. I'm starting to get pretty hungry. Okay, well, I'm glad that we finished baked lighting. So tomorrow we'll definitely be able to finish the rest of this stuff because it's all, even though it sounds pretty scary, it's all really simple. Basically just keywords. So maybe we'll get to custom lighting as well. That'd be nice. But yeah, we'll be done with the second video in the series, which will be really good. I don't think this last one will take too long because besides custom lighting, most of it is just optional stuff. I don't even know for sure if we'll talk about all these features because some of them might be better for a later or a separate tutorial, but we'll see. Anyway, yeah, thanks everybody for coming by and watching, and thanks for the chats. I think I'll be back tomorrow morning well, I don't know. I will be back tomorrow morning unless something weird happens. So I hope to see you then, and yeah, we'll finish up this part of the tutorial and maybe move on to custom lighting. I'll put some links in the chat if you enjoyed the stream and you'd like to connect with me on social media. Of course, you can check out my YouTube channel. I have a bunch of game development tutorials there, also stuff with the shader graph. Alright, thanks NTT, I'll see you tomorrow. Have a good afternoon. And yeah, alright, I'll see you then. Bye-bye. Alright, hey everybody. Hope you've all had a great Sunday so far and a good Saturday. Mine's been pretty good. My hair was totally wild this morning, so I hope you all don't mind. I'm wearing this beanie, but I didn't really want to get it all wet with it being so cold. But anyway, let's go ahead and get started programming. So last couple streams we've been working on the tutorial for my I guess not my next tutorial video, which is going to be on writing code shaders in Unity URP. It's split into 3 parts. One is kind of just like the basics of writing code shaders. The second part is more like advanced, trying to recreate the URP default lit shader. And then the final part is going to be about custom lighting and then other ways that you can like customize your shaders. So I did forget to open up the tutorial docs, so let me get that real quick. Okay. And then we'll open up part 1 just in case I need to refer to it for whatever reason. All right, so we're on part 2, and we finished just about everything. We have a little bit more to go. So we gotta implement the depth pass and the depth normals pass, and in the process we'll look at screen space ambient occlusion and screen space shadows. Yeah, it seems like the post-processing actually uses other ways to get the depth instead of the depth pass, so I don't think we'll end up talking about that in this tutorial. And then we have fog, decals. Oh, and I forgot stereo eye support, so we'll look at that a little bit. Can't really test it here on stream, so this is because I don't really have a way to show my the output from my VR headset, but maybe I could try to do that off stream. But all right. So I think last time we implemented the depth pass, and I was trying to figure out a good way to showcase how it works. And I was like, well, before I was thinking that we'd use the screen space ambient occlusion to show off the depth normals because it's better with that, but we can actually also use it in just depth only mode, and that will work fine just to force the depth pass to render. So when you add that here, then you can look at your frame debugger. And yeah, you can see the depth pre-pass is now running. And if we click on it, you can kind of see this faint red outline. It's a little bit difficult to see unless you zoom in really close to an object, which is why I've moved this. But yeah, so if we go like that, you can see it's rendering the depth of these objects. So basically, the more red something shows up, the closer it is to the camera. And you can use that for all different kinds of effects. Oop. Okay, so let's add this to the 2021 version just to make sure it's all working. Don't have to copy that just yet. Okay, I think that's all we've changed so far. And don't worry about those errors, they sometimes just pop up. Okay, yeah, and then we zoom in, you can start to see. So it's interesting. I don't think so. Transparent objects shouldn't be reflected in the depth only pass. Do I have any transparent objects still on the? Okay, I don't think I do actually. Yeah, they should all be opaque now. So is this one uses? Okay, so yeah, I want to change this back to transparent blend. Okay, and I guess I have to switch back to scene view. Okay, and now, yeah, even though I'm right up next to the transparent object, you can see it doesn't show up here. Oh, hey, Steph, thanks so much for the subscription. I appreciate it. How are you doing today? Yeah, I was a little, well, obviously, of course, with my new schedule, it does kind of hurt the growth of the stream, but I'm glad to see some people still are enjoying it, so thanks everybody for watching. Okay, but anyway, so it does work. Let's go ahead and talk about write up this little part. Oh, I just realized, okay, I have a bot that's supposed to turn off the emote only chat and stuff when I'm live. For some reason that didn't go, so I'm sorry if anybody's been trying to chat. Okay, I guess I need to have a mental note to check to make sure the bot is actually working when I go live. Yeah, and I have to do that because apparently you can get, our Twitch can ban you if you don't moderate your chat even if you're offline, so you have to kind of just disable it. Okay, well thanks, Steph. Okay, so there are a couple more shader passes the lit shader has, which enable different post-processing, I guess just different effects. For example, let's see. There is, I'm trying to think out how to, I guess I can just go ahead and explain like what screen space ambient occlusion is. There's a cool renderer feature which adds screen space ambient occlusion, or SSAO. This automatically generates or this automatically lowers occlusion for in creases between meshes, and can really have a big impact on your scene. However, screen space ambient occlusion requires either a depth pass, requires something called a depth pass, which renders the distance a fragment is from the camera. I don't know, that doesn't sound like a great way to say it, but we'll go with it for now. Yeah, remember, colors are, remember, textures just store colors, and then colors are just numbers, so we can encode any information in textures we would like. Actually, now that I think about it, I don't think I've actually talked about rendering into a texture. I'm trying to think. Let's look back. I guess I kind of did because when I did the shadow casting, I wonder if I mentioned it. Okay. I kind of just say it for granted. I don't know if it's obvious that they can write textures. I should probably say. Okay, let's see. So the rasterizer then sets the data. Fragment function, which runs during the fragment page, should look like the fragment stage should look like this. It takes an interpolator struct, blah blah blah. The fragment function outputs a float 4. The color of the pixel. Okay. So yeah, that's the target. But I'm trying to see, like, do I talk about it ever rendering to the screen? Let's see. Okay, yeah, so the graphics pipeline controls how a mesh and material go from a blob of data to a picture on your screen. Each stage has a specific job. Okay, the vertex fragment stage. So let's start. The input assembler, vertex stage. Okay, so it should be rasterizer, pixels white. Okay, I guess, let's see, the last stage is the presentation stage, which takes the output of the fragment function and information from the rasterizer to place all the colors on the screen. It can also render to a texture, which another shader can use. These textures are called render targets. These two options are collectively called render targets. Okay, anyway, I'll come back and talk about that. And then maybe I can just mention render targets here in the Shadowcaster. User will have to write a second pass which renders our object shadow to the shadow map. Which is a special texture containing shadow data. Okay. However, screen space ambient occlusion requires some kind of special data to run. One option is a depth texture. This depth texture contains distance from the fragment to the camera and is rendered by a special pass called the depth only pass. Okay, let me just say, remember, let's write this depth only pass. First, create a new HLSL file to hold it. And then, okay, add the standard. Okay, let's see. Okay, so we got the guard keyword and then includes. I guess I'll just put this somewhere so I can kind of see it. Okay, so add the standard guard keyword as well as include lines for the URP lighting library and our common file. For attribute, okay, so this pass only outputs depth, so we just need position from the mesh as well as main texture UVs for alpha clipping. The interpolators struct only contains clip space position as well as UVs once again for alpha clipping. Okay, not that really matters, but let's leave it like this. Okay, so the vertex function is very simple. Just compute clip space and and UV. Okay, I don't know. I'll brain freeze there. Just compute clip space and tile the UV. Okay, the fragment function is even simpler. It always outputs 0 after testing for alpha clipping. You might wonder how this actually outputs depth information. Okay, that's actually, I'm trying to think of a good way to explain it, because like, oops, that was the wrong window. Because yeah, the depth texture doesn't actually have color, it's just that it only has like a depth channel. never really explained, I don't think. Okay, so actually, now that I say that, I shouldn't really do... It's actually different. It's not... doesn't actually render the texture. Okay, so we'll just leave it as that for now. Okay, so this texture, most render targets have a fifth channel. Oh, that's not really the same. Let's see. I'm trying to. They like have like the depth attachment, which is like another texture that's kind of. I guess it's just another texture that's paired with the color. I'm trying to think. I don't want to give the wrong terms here. Because I think only the camera has a depth attachment, actually. Actually made up of two textures, color and depth target. Let's do this. The color target is what ultimately ends up either on the screen. I guess usually, actually, this is a example of when it doesn't. While the depth target contains this depth information and is used to prevent okay, so this is another thing. I don't know if I ever talk about I guess I kind of do here in the Shadowcaster. It's basically just like the Shadowcaster now that I think about it. Okay, so now I need to tell Unity a bit more information about this pass. Let's see, you might have heard about the depth buffer. It's kind of like a texture the GPU maintains of the screen where each pixel encodes the distance from visible geometry. Okay, let's not use this. Let's of the render target. Encodes the distance from visible geometry to the camera. When a fragment function returns, the URP stores the z-coordinate of the clip space position in this buffer. Buffer is used to make sure a triangle doesn't overwrite one closer to the camera. Before writing color data to the screen, the render compares the fragment z-coordinate to the value already in the depth buffer, making sure this fragment is closer to the camera. The reason this is relevant now is because we can tell Unity to only write to depth for the Shadowcaster pass. No need to bother with color. This is basically telling the render to write no color. By default, the color mask is set to RGBA. Okay. Normally, the depth buffer is discarded when the render target is fully rendered. However, in the shadow caster pass, URP actually discards the color buffer and stores the depth buffer in the render target. This is why we don't care about returning color in the shadow caster fragment function. Okay, so actually kind of already explained a lot of this stuff, so I don't really have to talk about it again. 0 after. So remember how the shadow caster only cares about depth information and discards color. The depth only pass works the same way. So why is it saying that? Oh, yeah, that should be a period. Okay, so alright, so that makes that simpler. I don't have to explain everything. Let's see. My head's like creeping off my head. Okay. Okay, so the depth only okay, it's pretty simple. The pass definition for the depth only pass is also pretty simple. First, set the name and light mode to depth only. Turn set Z right to on, color mask to 0, and cull to the cull property. Register, add pragmas for the shader. What's it called? Shader model. Alpha cutout, shader feature, and the vertex and fragment function registration. And then finally include the HLSL file. Okay, in Unity, you won't notice anything different. Most likely the depth only pass doesn't render You can take a look in the frame debugger. To get it to render, we need to add some feature that requires it. Let's see. Hi, Odin. It's been a while. Yeah, it has. How are you doing today? Glad to see you again. Like screen space ambient occlusion. Select your URP renderer settings asset and add a SSAO renderer feature. Set the, what's it called? Set the source to depth. Source field to depth. You won't, okay, so our shader doesn't use SSAO yet, so you won't notice anything visible, but in the frame debugger, you can verify that the depth only pass works correctly. So let's add SSAO to our shader while we're here. You're writing a shader in URP now. Use my tutorials a little. Oh, I'm glad to hear that. What kind of shader are you making? Okay, so let me commit the changes I've done so far. So this is depth only. Okay, so let's call it 16.1 depth. You're writing a simple lit shader for your mobile game. Very simple. Okay, well, that's good. Definitely good to start simple anyway. Let's see if I can. Right. Yeah, I need to save the scene so that it adds the stuff I've done. There we go. Okay, so now screen space ambient occlusion is very simple to support. All we have to do is pass the lighting data, the screen space UV. Looks like I forgot to include this comment before. Not that it really matters, but I'll go ahead and add it in. Okay, so that's all I have to do. I might as well just go ahead and add it here. Oh, well, that's not true. We actually do need to add a keyword. Yeah, screen space occlusion. Okay, so in order to get this to show up, I just need to, is this one static? No, so I can just move it. Okay, yeah, you can kind of see the shadow on the sphere. And that's from the screen space occlusion. And then if I, yeah, so you can see it happens where it kind of intersects with the ground. And then we can kind of verify that it works by going to the frame debugger. Oh, except we're zoomed out. Okay, and then screen space ambient occlusion has a bunch of different passes, but the final one shows you kind of the ambient occlusion. And this is kind of like a multiplier to baked lighting. Okay, let's verify that's working here too. Here. Okay, yeah, you can see the shadow again when it intersects with the ground. Yeah, the SSAO is a bit more pronounced here for some reason. Unity changed a lot of rendering in 2021, so it's not that surprising it looks a little different. Okay, so yeah, that's pretty simple. We don't have to change much. First, add another renderer. Oh, wait, another shader feature to your forward lit pass. Then in the fragment function, we need to read the SSAO for this fragment. Since SSAO is a screen space texture, hence the name, which means one pixel on the texture corresponds to 1 pixel on the screen. We need to compute this fragment's screen space position. URP calls okay, well, that's actually not exactly true because we want to calculate, well, I mean, it's sort of true, but screen space is confusing because there's a bunch of different terms for it, and for like different versions of it. This time we kind of want to treat it as a texture, so we want to find the UV position on the screen. So we need to compute this fragment's screen position as if it was a UV onto the a screen space texture. Okay, so URP provides this function to do exactly that. Pass in the clip space position and store the result in the lighting data structure. That's right? Yeah, clip space position. So remember that in the fragment stage, the clip space field contains this fragment's pixel position on the render target, the screen in this case. I don't need a... I messed up the apostrophes there. Okay, let's actually flip this around. So URP provides a function to transform it from pixel position to UV position. So yes, then I'm gonna say store the result. Okay, so back in Unity, I guess move one of your objects, or okay, so move two objects close so that they intersect. You should see a shadow up here in the crease. You can also verify SSAO is working through the frame debugger. The last event in the SSAO dropdown shows the final SSAO texture that are shader samples. Okay. All right. To get better quality SSAO textures, we can provide another special texture called the depth normal texture. This texture stores depth, or stores a normal vector for every pixel of visible geometry. SSAO can use this to better find creases where occlusion, or let's see, baked lighting should be darker. Okay. For highly northwest, what do you use depth normals pass? As far as I know, Unity doesn't transform normal tangent to normal world space in the forward renderer. Without this, SSAO does not look very good. What do you advise to do? It's actually, it's interesting you bring that up, because Unity basically how they do it changes between versions. Let me check. I guess it'd be in this one. But unfortunately, if you want to use the SSAO that's built in with URP, you kind of just have to do whatever they require for that version. Hey, thanks for the follow, Jeff Bull. Okay, okay, so you can see, yeah, so if you're in 2021.2, it either outputs world space normals, basically just unencoded world space normals, or it will packet, and this is if you're in deferred mode. I went ahead and just supported it, but you know, I don't actually support deferred mode in this tutorial. But then if you're in before 2021.2, then yeah, it uses view space normals. At least in URP. It doesn't even use tangent space at all because it doesn't have the normal map. So I don't know if you saw what they changed on GitHub. Okay, let me take a check. Alright, let me take a look at that. Okay, this was last April. Okay, so yeah, so they have like parallax. I guess I should show this on screen. Okay, so yeah, they view direction in tangent space. Okay, well, that's parallax. Yes, this is okay, so world space normal. Okay, that's interesting. Yeah, this is different than what's in the final version, at least that I have. Let me see. It's in the shaders. Yeah, so this is a depth normal pass that's okay. Well, actually, no, it's not different. Okay, that's it. Huh. So it does do the normal map. Okay, this is actually changed since I last looked at it because I used to have normal map support, but then I removed it because I thought that they didn't do it, but maybe I was looking at the wrong thing. I don't know. Okay, but let's take a look at this. So, okay, so this is alpha clipping. Then this is for deferred rendering. Okay, and then they have parallax, which I'm not really dealing with in this tutorial. But basically it's just a way to kind of modify UVs based on a depth texture. Okay, so then if it has normal maps, then we first calculate the bitangent, and for some reason they don't use their own function to do that, but then it samples the tangent space normal. Okay, and then it transforms tangent to world space. Okay, so yeah, they only do this for the deferred render, but it could be done for the forward render as well. Okay. Because let me see. So the lit shader, go down. Okay, so the depth normals pass. So it does use this lit depth normals pass HLSL. Okay, well I'm kind of annoyed now because I removed this normal map support because I thought they didn't include it. But I had this in an earlier version of my shader. I mean, I guess we can add it in. It's probably not too late. But yeah, doesn't transform normal TS to normal world space in the forward renderer. So you're saying that it just outputs, so in the forward renderer, you're saying that it doesn't do or deal with normal maps? Because looking at this code, it seems like it should, because yeah, this G buffers is the deferred mode. And then so this should be what runs during the forward mode or forward renderer. Okay, so anyway, let's see what it would take to add back in normal maps into our shader. It's not that difficult. Okay, first let's close this. Basically all I have to do is, that's kind of why this apply normal map was in a different function, but I can remove this and add it back here. And then depth. Okay, so I still got, yeah, you can see I hadn't completely converted away from it because I still have the tangent vector here, even though we don't really need it anymore if we're not going to read from the normal map. So then this would be float 4 tangent world space text chord 1. So again, I want to go ahead and copy. So for some reason it looks like the depth normal pass doesn't sample the normal map in this gbuffer mode. So I don't know why, but have I tried Rider for shader coding? No, I haven't. A lot of people have recommended it, but it's just too expensive for me to justify. And like the company I work for doesn't use it either, so. I'm curious if there's a reason that they don't sample a normal map for this besides just efficiency. I'm just wondering if I need to do this for forward render without this tessellation and SSAO look bad together. You're thinking of adding the high quality depth normals global setting to my shaders. I'm not exactly sure what that setting would do, but I would say if you're having issues, you might as well. Do you tessellate the depth normal pass? Because I can see like if there was a mismatch, then that would also look bad. Okay, you do tessellate it. All right. Trying to think, like on my tessellation tests, I don't know if I ever noticed any problems really, but I mean, I guess if you're seeing them, then maybe there definitely is. Oh, thanks, Jeff Bull. I'm glad to hear you like the tutorials. But I guess to answer your question, the Nost West. I would just try out things to see what looks best. It's kind of hard to know for sure. URP doesn't really have many best practice documents, but I guess at the end of the day, you kind of have to output world space normals in the depth normal pass for SSAO to work. You'll send screenshots. Okay, well that might help. Maybe I can give you some advice that way. Okay, so anyway, I was gonna do are apply the normal map to our depth normal pass. Okay, so the lit shader does not apply normal mapping to the G buffer. Mode. I mean, I almost like don't even want to include this in the tutorial because I'm not talking about deferred at all. But doesn't, yeah, so the G buffer pass, does it not have its own? I'm trying to see. Oh, okay, of course. I was gonna say, I was trying to see like what was exactly in the fragment output structure, but yeah, of course it's not here. It's in Unity G buffer. Okay, and then of course I don't really say what's in it. RDF data to G buffer. I haven't really looked at their deferred mode, so hopefully that, okay, here it is. Oh, that's from, okay, so albedo and material flags, specular and occlusion. Okay, so they do put the normal in this G buffer. So I'm not sure. Well, I guess you still have to have a depth normal pass on deferred mode that runs. Or do you? I'm not sure. I need to look. It's been a while since I've worked with it, but I don't know why they would have, like, even run the depth normal pass if you're in deferred mode. But you upload screenshots. Okay, let me see. Okay, so tessellization plus depth normals with normal tangent space, and then without. Let me see. Let me open them in another window because this monitor is not the best quality. Okay, so I see. Yeah, that is a pretty big difference. Yeah, and you have pretty extreme tessellization going on there to get such a deep cavity. What's my opinion on built-in versus URP? I mean, they're both fine. I guess I think Unity is going to like deprecate built-in at some point, so that's kind of why I focus more on URP. But I mean, built-in, I have nothing against it. Oh, okay, so what are these next images? Oh, is that the actual depth normal output? Gosh, my hat is a little... it's starting to look like a little elf hat or something. Okay. Anyway, so I'm just thinking, I kind of want to remove this from the tutorial because I don't want to explain what all this is doing, and I don't even know if the G buffer is ever turned on. And I don't think it's ever... Okay, that's not what I want to do. I'm trying to see if I can find any documentation on this to see like when it's turned on. I'm not going to hold my breath. The debuff full normals oct is... Okay, so it is a forward render mode? Okay. So I guess I better support it then. I just don't know when it's turned on. Okay, so it's in the shader keyword strings. Maybe I can see if I search through everything. Okay, so shader. Oh, there it is. So this one is in universal and shader graph. Okay. Okay, so here it is. So hopefully if I find references of this, you can see where it's turned on. Okay, so shader preprocessor. Okay, so it's only turned on in the deferred light class. So accurate G buffer normals. Disable any global keyword setup and setup lights. Okay, so it seems like it's only turned on in this deferred lights class. But I don't know. I need to look. Like I said, I haven't really looked at the deferred renderer in URP. I haven't had a chance to see how it works yet. Yeah, that's true, the Nost-West. There's a multi-compile. I'm just not sure. I mean, I guess it's not that big of a deal. I just don't know if I want to include it in this tutorial. Because it's gonna, you know... I'm just trying to think, like, for length, like, do I need to support this mode if I'm not supporting the deferred renderer? Even though, let's see, like in the lit path, or in the lit shader, it does have that multi-compile. Or does it? could be a... Oh, well, this is the shader model 2.0. It should be this first one. So the G buffer. Oh, I just want the current document. Okay, so it actually doesn't do that. You can find it in the SSAO shader as well. Okay, it definitely is there in the horizontal blur. And yeah, the main pass as well. Okay, so it seems like it's some global keyword. It's interesting. Oh, it's right here. Yeah, on the G buffer mode. Okay, so for some reason they also have it in the depth normal pass, even though it doesn't seem like it's ever turned on. Alright, well, I think I'm gonna... This is my... Yeah, I think I'm just gonna delete it. Because I don't think it will affect anything, and I don't really want to spend time explaining what a G buffer is, because we're not doing anything deferred in the tutorial. But I guess probably someday I'll do a follow-up which will explain deferred rendering, and then maybe we would talk about this. Yeah, it is important for a deferred renderer. I'm just, like, this tutorial doesn't even mention the deferred rendering mode, so if I ever did a backup, or not a backup, a follow-up, I would definitely talk about it. Okay, so, oops. Let's change this. So yeah, there's output normal. Maybe I should. Now I'm afraid that if I do a follow-up, I'll forget to add this back in. Don't know. Okay, let's see. I'm not sure why this is going to pop up on the screen, so I'm just going to I'm going to open my note-taking and just so I can remember. Okay, so... Okay, sorry about that. Okay, so let's add notes for a deferred follow-up. Remember to add oct support to the depth normals pass. I'm sorry, the formatting on the the comment is making that difficult for me to read. So okay, so if defined, I guess that's what that's the code I had a second ago. I just don't think it's actually in the I don't think it actually runs in the forward renderer because you can see on the shader, it doesn't have a shader feature for that here. And then also it's only turned on in this deferred lights. Yeah, so the only time it's ever turned on is when deferred lights is running. Yeah, setup lights, which I assume isn't called when the forward render. Yeah, so if rendering mode is deferred, then setup lights is called. So if we're not in deferred mode, then this function's never called, and so it can never be true. So unless there's some other code path that's hidden from me that this can be true, I don't think this is ever turned on for the forward renderer. Yeah, that's right. So before 2021.2, they just returned a view space normal. Yeah. But then in 2021.2, they return a world space normal in the forward render, and then if you have that option on in deferred render, they do that encoded thing. Okay, so I want to add normal map support here. So I'm not sure, like I said before, I thought that they didn't do normal mapping for the depth normal pass, so I had to remove this code, but they actually do, so we'll add it back now. Okay, so I guess I can just grab this code. Okay, so let's see. We can, let's see, normal mapping is only applied in 2021.2, but you could do this in 2020.3 if you'd like. Okay. Okay, so we got the normal, the tangent, sample it. So we have, okay, so now we need the UV even when alpha cutout. So now we need the UV when alpha cutout is true or we're in this version. So let's see, so if defined alpha cutout or then we'll do define require UV interpolator. I don't have to add a semicolon there. Let's add this. So we only need UVs for alpha clipping or normal maps. You can see that the normal map and depth normals is only calculated in deferred renderers. Okay. That's interesting. I don't know, I feel like I need to do a lot more research because like this code seems to me that the normal map is not added in deferred mode, but it is added in forward mode. But then again, okay, so then like they store normals in the second, or I guess third G buffer. So I guess normal vectors would go there, but then they don't when they have a separate normal path. It looks like there's no normal map. I don't know. It's a big. Like I said, I don't feel qualified to really speak about the deferred render because I haven't really researched it. Okay, so anyway, so this should be input.uv. Let's see. So hopefully this will work. I can switch deferred to forward and see the effect. All right, maybe I'll have to go and do that, but I mean, definitely it's something I should look into when I do a deferred render follow-up. Okay, so no errors, that's good to see. Let's switch to one of my showcase scenes just to make sure everything still looks good. Okay, this is supposed to be opaque. Is it adding? I don't see the normal map, but maybe this. Okay, so the normal map is definitely there, but for some reason not showing up. As I understand, depth normals should not be in the forward renderer. It's more like a hybrid renderer. That's true. They only have depth normals for screen space ambient occlusion in forward rendering. So I mean, yeah, it's kind of a hybrid renderer because it still, you know, renders out the depth normal texture. Kind of like you know, how it would render out the depth buffer. Okay, what's this? Okay, so that's just clearing the depth buffer. Okay. Let's test this out on a simpler object. Okay, so it has. Okay, and these other two I think are, yeah, default lit shaders. So if I add test normal here. Okay, so you can kind of see the waviness there, I think, is from depth normal, but okay, so it shows up here, but not here. So what have I done wrong? Okay, actually, I probably don't need to normalize again because I think I normalize in this apply normal map function. Yeah. Okay, let me... Anyway, I know this is wrong, but I'm gonna just copy that out to see. Okay, yeah, so now you can see the normals are facing the wrong way. Just wanted to test. But how come... Like, I obviously call it here, and I pass in the normal map applied. I don't have any other little keywords. Maybe... Is it... Oh, I don't store the tangent space here. Okay, that was it. Or the tangent vector. Okay, and I also gotta get the bitangent flip bit. There we go. Okay, so I guess I really only have to output this if we have normal maps. Okay, so I guess I should be good. Because yeah, adding another or removing a interpolator when you don't need it is actually a pretty big optimization. Okay, so if so now I've got an error. Incorrect number of arguments. I probably just made a typo. Oh yeah, this should be the normal inputs, not the output tangent world space. Okay, there we go. So now they're applied. I just, yeah, the tangent vector was always 0. So, okay, so you can kind of see now we're getting some SSAO and the dips of this, of the ground. Okay. Alright, well I'm glad I caught that. Thanks for bringing that up. The Nost West. Okay. I don't know what I was reading before that made me think that that didn't apply the normal maps. I probably was just looking at the wrong file. I don't remember, that was a while ago, but anyway. It's good now, so. Let's see. Okay, so where was I? Did I commit the changes here? Okay, no, so I need to commit the changes I did for the depth only SSAO. And tag 16.2. I guess I should just go all lowercase. Okay, so now I need to basically add in the depth normals paths I just created. Let's close this stuff. So my depth normal, oh wait, my lit depth normals pass. We'll include most of this, except I haven't done instancing yet, so I'll take that out. And then here, need to add the new depth normal pass. Okay. Yeah, while I'm here, I get rid of this header. We don't really need it for this tutorial script anyway. Okay, so and then we don't need multi-compile instancing. Oh yeah, and then the other thing I need to do is move this out and into the common file. Okay, so there we go. And then to test it, I can change this to depth normal mode. Okay, then we can see the SSAO still works fine. Okay, and then the depth normal pass. These, it's hard to read these normals because they're view space, so technically they should always point like they're relative to the camera basically, but then they're also encoded in a special way, so it's the colors don't actually mean like where they're actually pointing, so it's kind of hard to read them in 2020.3. But okay, so let's add this stuff to the 2021.2 version of the shader. So I have to have the lit common and then the actual shader file. And then the for lit pass, a little different. And finally, I have to create the depth normal pass file, which is the last pass we'll create for this shader. Lit depth normals pass.HLSL. Cool. Okay. No errors, that's good. Depth normals. For some reason that error always pops up in this version. Get rid of that. There we go. And I guess if we switch, you can kind of tell a little bit of a difference. So for one, the depth only mode, it kind of has, it's a little fuzzy and pixelated, but the depth normal mode is a little cleaner. And also this version takes into effect normal maps, and also the ring like around the edge of objects doesn't get quite as much occlusion, which makes sense because I mean, occlusion should only happen where there's creases, but when you're using only depth, it can't tell for quite as well what's going on. And then yeah, here we have our normal depth pass like we'd expect. Wait. How come? Okay, it looks like there is, you can, I don't even know if you can see this on Twitch, but there's slight normal map. Okay, so normal strength is actually wrong. Okay, see, it is working. It's just you can't, because it's so green, you can't really tell on the ground, even though it has full normal map strength. But I guess if we looked here, I could turn this off and you can see those spots on the ground disappear. So yeah. This isn't really on the spheres. The normal map doesn't seem to affect it, but you can definitely see it happen, or see the normal map being applied. Anyway. You can add a global keyword to enable a disable normal map and depth normals. Yeah, that's true. I haven't done that in this shader, but yeah, it's definitely something to look into. But yeah, the default lit shader does have something that basically the editor turns that on and off depending on if you have a normal map. What's it called? Like slotted into the normal map field. I guess I can just, yeah, so if you have something set here, it turns on and off that keyword, but I don't do that in my shader. Maybe I should, but I don't know. I'm trying to keep it relatively simple for the tutorial. Okay. Depth, normal texture. This texture stores a normal vector for every pixel of visible geometry. Can use this to better find creases where baked lighting should be darker. Don't know what I was going to type here, but let's create another shader pass. Create my lit depth normals pass HLSL. I always forget, do I add the S or not? Depth normals. Okay. And add the standard guard keyword and hash include lines. It is the standard ones, right? Yes, okay. Okay, so I'm trying to think. I think I'll write it first off without alpha clipping or normal maps, and then I'll add it in. Just to make it easier to explain. Let me put this up so I can refer to it while I'm writing. Okay. So for attributes, this time we need position and normal vector. And as for interpolators, we need a clip space position and world space normal. In the vertex function, oh wait, I just realized I need to get rid of all that stuff because that's instancing, which we don't do yet. Okay, I'm glad I caught that before I committed my changes. Okay, so in the vertex function, convert the position to clip space and the normal to world space. Okay, so in the fragment function, we need to output the normal. Remember that colors are just numbers, so we can store whatever data we'd like in them. For the depth normals pass, we store normal vectors. Okay, the specific type of normal vector is different depending on your Unity version. In 2021.2 and later, URP uses a simple, that's not how you spell simple, world space normal, attack on a 0 for the alpha, and I guess I should say normalize and attack on a 0 for the alpha. In 2020.3, however, URP stores normals in view space, which just means they're relative to the camera. I guess I should say uses normals in view space. They're also encoded in a special way to help with how do I want to say it? I guess precision. Thankfully, URP provides functions to take care of both these issues. All right. Also, in our Unity 2021.2, they began adding normal maps to the output. Okay, you can also, in previous versions, but your shader will behave differently than the default shaders. Anyway, for this, we'll need tangents. So add them to your structures and convert it to world space in the vertex function. SSR and URP is under consideration. I wonder how they'll make it. Will it be for forward render like SSAO? Let's see. I always like to look at this board every once in a while to see what's going on. So you can see they added a ton of features in 2021.2. Actually, I should talk about this depth prepass. Okay, well, we'll do that later. So depth prepass, and then we also have screen space shadows, which I was already planning to talk about. Okay, and then yeah, so we've already done most of these. We don't really talk about motion vectors because I don't think you have to add any special support for that. But anyway. Oh, and I love this material variance. I'm so glad that they finally added that. But anyway, okay, so in progress, they've got... Okay, so this is nice. The pipeline and render data assets are adding together. So LED crossfade. Oh, they're finally adding this. Built-in converter improvements, rendering layer support. Oh, finally, they're adding this instead of Unity's default layers. I thought they were never going to do this. Okay, I'm super excited for that. Because I use layers for like my hull outlines, and people always comment that they hate having the collision layers be the same as the rendering layers, so they're finally separating that out. Okay, temporal anti-aliasing, real-time upscaling, decal layers, forward plus renderer. So I think this is where it's still forward rendering, but they kind of combine lights into groups so that you only have to check lights that are close to your object. I think something like that. Oh, surface shaders, this will be nice. This is like, basically it makes it easier to write code shaders. Then custom post-processing. Okay, so plan, they have motion blur, shader quality, settings, more documentation. Okay, so that should be in progress, but we'll take it, I guess. Exposure. Okay, and screen space reflections. Let's see. SSR is an alternative to cube maps and reflection probes to render reflection details of a scene. Accounting for reflections in a scene improves the quality and accuracy of physical-based rendering significantly. Can provide more performant real-time reflections in cube maps. It does not require the cost up front. Blah, blah. SSR technique works better with different shapes of surfaces and provides better accuracy of self-reflection. SSR comes with its limitations and artifacts. I would guess it's probably going to work like SSAO. So hopefully it'll be for both forward and deferred. I would guess so because they're even adding this forward plus mode, so I kind of doubt that they would want to lock it out from SSR, but we'll see. Blob shadows, okay, cool. HDR. Okay, so this is kind of interesting. They're adding this to URP. This is where all positions are relative to the camera, and it kind of helps with like large open world games because the world is so big that you can start to get floating point errors when you're far from like the origin of the scene. And this is like how it works by default in the high def render pipeline. So okay, and then volumetric fog. Cool. Well, it looks like they've added some stuff since I last visited, so good to see that URP is still in progress. Let's take a look at their high def. Okay, they added a ton. Okay, this is also released. A lot of stuff. I want to try HDRP. I've barely gotten to work in it at all, because neither people on my YouTube channel or my job don't seem that interested in it, but someday. Okay, so yeah, water, DirectX 12, full screen shader graph, denoising, some more path tracing, ray tracing stuff, surface shaders, pair, volumetric fog, motion blur. It's kind of interesting. HDRP seems to have less like engine features and more just like extra little things to do. Whereas URP, they're still working on like the lighting plus mode, which is like a big engine feature, and then also SSR. Anyway, it's just interesting to see. Okay, so what was I doing? Oh yeah, I was talking about normal mapping. Okay, to apply normal mapping, let's move the, what's it called? The apply normal map function from the forward lit HLSL file to the common HLSL file. So we can call it in this fragment function. Okay. Now we'll also need the UV. So move it through the vertex function as you would normally. Finally, return the adjusted world space normal, and okay, it no longer needs to be normalized before returning. Okay, one last thing. Alpha clipping. Alpha clipping also requires the UV, so let's define another keyword just to control whether we deal with UVs or not. Okay, so yeah, modify your structures and the vertex function accordingly. Then add this code to test for alpha clipping before calculating the normal vector. Okay, so yeah, I'm kind of going quickly through this because we've already talked about all these techniques previously in the tutorial, so there's no reason to really spend a lot of time on it. Okay, so back in Unity, change the SSAO type to depth normals. Then, okay, you might notice a small difference. Use the frame debugger to make sure everything looks good. Here you can really see the difference between the two SSAO modes. Depth normals usually provide better quality results, but the depth normals texture is more expensive to render. So let's see, The choice is yours. Okay. So, all right, the depth pass is also used. Okay, let's see. These passes are also used for some other effects. For instance, in 2021.2, there is a depth pre-pass renderer feature, which can be useful if you have very intensive shaders. It makes sure only the fragments closest to the camera are ever rendered by filling the depth buffer fully before calculating color. Okay, so let's make sure that actually does use the depth normal pass. I guess I should have done that before I wrote it. Okay. So depth normals. It took a lot longer than I... Oops. No, I don't want to push. It took a lot longer than I was expecting, but... Okay, so 16.3 normals. All right, so okay, sorry. Just trying to decide what to do next. So okay, we'll turn that off. Okay, I thought that there was a depth pre-pass render feature. Yeah, right here. See if I can figure out how to enable it. Okay, so it's in depth priming mode here. Okay, so I guess we'll turn this off because I want it to just be simplest. Okay, so wait. This is the okay, so it's in the render asset, not the settings asset. We're also very interested in GTAO and SSDO, screen space directional occlusion. It's something like screen space global illumination to me. Yeah, I've read a little bit about that. My mind's going blank on GTAO. It's something ambient occlusion, obviously. I haven't heard that Unity is planning on releasing either of those, but you could definitely write it yourself, I'm sure. Okay, so alright, so now I have depth priming mode on, so let's make sure that it actually runs how I expect. Okay, yeah, so the depth pre-pass. There we go. Okay. Okay, you can enable this in your renderer asset by turning depth priming to forced. Once you do, notice the depth only pass appears in the frame debugger. Okay, so it's gonna complain about that, so I've gotta put in quotes. Okay, all right, the other big feature that relies on the depth texture is screen space shadows. This technique like compiles all main light shadow cascades into one screen space texture that that you can sample. This can be more efficient depending on your hardware. Okay, so 2021.2 feature. This should be this technique. Okay, so we need to add some features to the shader. Okay, so we need to, I guess, change the shader a bit to support this. Okay, first add another keyword to the main light shadow shader feature list. Then, okay, well, I guess I should actually just implement it. Let's move this back to this screen. Okay. So first of all, for screen space shadows, you've just got to add another keyword. Then, in the forward pass, so now we've got to add this shadow. Is this right? Yeah, the shadow coordinate. This is what I was looking for. Okay, and I'm also so I have these helper functions. It's actually kind of, yeah, to do main light shadows, you actually kind of have to add a lot. Let's see, what was the order? Or screen space shadows, I mean. Main light shadows are simple. Okay, so what you have to do here is in the vertex function, if we have screen space shadows, you need to compute the NDC coordinates, which is kind of like screen space coordinates. But in order to do that, we have to have the clip space position from the vertex before it gets converted to pixel space position. So that's why you have to do it in a separate interpolator. It's also not the same as this value, which is a little bit even more confusing. And then in the fragment stage, if we have a shadow coordinate interpolator, we just return that. Otherwise, we need to convert to shadow chord. Okay, and then this is if we have no shadow, we just return that. Okay. Okay, and then got two. Okay, and then yeah, instead of just calling transform world to shadow map like we did before, we just call our get shadow chord fragment function, and it will take care of everything. Okay, so I think that's all I have to do. Again, nothing should change in 2020.3 because there's no screen space shadows. Okay, so let's copy these changes to 2021.2. Oh, that was the wrong pass. Okay, so all good so far. We can turn back on SSAO. No screen space shadows. Okay, well that's not a good sign, so the shadows disappear. Or do they? Okay, they're flickering. Okay, so it seems just to be an effect in the renderer. Okay, you can still kind of, I don't know if you can see this on Twitch, but there's still this line right there, and I think that's just where the shadow cascades change. I kind of see flickering when I move back and forth. I don't know. Does that happen when I turn off SSA or SS? I guess SSS, screen space shadows. No. Okay, that might just be a limitation of it. Let me look. Frame debugger. Oh, yeah, it's not going to show up. Okay, that's kind of funny, but I think it's because certain things aren't updating because I have it paused or something. Okay, so which of these? This is the default. Yeah, this is just using a default lit. Yeah, the sender sphere is using a default lit object or material, and it still gets that the flickering, so it's not my shader, it's just the way that this is done. This is a funny effect. Okay, well, I mean, since the default lit shader has this flickering, it's not my fault. So, I mean, yeah, screen space shadows are slightly less efficient, or not less efficient, they're less quality. Okay, then, in the forward lit pass, in order to support green space shadows, we need to add another interpolator for a shadow coordinate. This must be calculated in the vertex stage because it requires clip space position before it's transformed to pixel position. Let's okay. We can use a keyword defined by URP to know whether to use this interpolator or not. Let's write a function to calculate the shadow coordinate in the vertex stage. If screen space shadows is enabled, call this function, which calculates a screen space position, or which calculates something called normalized device coordinates, which is similar to screen space. This is what the screen space shadows texture expects. Okay, it's not the texture, I guess it's the system. If for some reason we're calculating a shadow coordinate, but screen space shadows are not on, just return a shadow map coordinate. Okay, so in the vertex stage or function, call your new function and store its results in the interpolator's structure, only if the interpolator field exists. In the fragment stage, we need a similar function to switch between the various, gosh, I can't type, shadow coordinate modes. Let's see. So if we have a shadow coordinate interpolator, return that. Otherwise, calculate shadow map coordinates like before. Then finally, if there's no main light shadow, we can just return 0. Okay, so replace the old shadow chord function in the fragment stage with this one. Okay, so back in Unity, add a screen space shadow renderer feature and try it out. This might improve performance, but you'll probably notice more shadow artifacts. The system doesn't work perfectly, but if you have a camera that doesn't move around too much, it might be perfect for your game. Okay. So I think that's about it. Okay, the depth and depth normals. Textures are also used by other effects, and you can use them yourself in custom post processors. It's a good idea to implement these passes even if you don't plan to use any of the features I showed off here. Okay. So as you understand it, BakeGI and light probes work separately. Why can't it be wrapped somehow? And if so, are there implementations? Well, technically light probes are just another, I guess, like data stream or component of BakeGI. Do you mean like, yeah, so I don't think in Unity you can ever have light maps and light probes on the same object. At least the lit shader doesn't allow that to happen. Because you can see, well, this is my shader, but the default lit shader works the same way. There's this macro here, declare light map or spherical harmonics, which is this fancy term for light probes. So you can either have one or the other in your interpolator structure. But I hope that answers what you were asking for. Gosh, I need my throat's starting to give out, so let me get some water. But I think the reason that they don't support both is partly for, or both at the same time, is partly for performance, because they don't have to calculate light probes for static objects because they're kind of already tied into the light maps. And then dynamic objects can't get light maps by their very nature, so there's not really a reason to support them. Yeah, I'm trying to think if there's a way that you can override it for yourself. I haven't looked into that. So, I can't say off the top of my head. No problem, Noswest. I hope that did answer your question. Okay, so let's commit the changes so far. And I think we're done with that. So now we've got to handle decals, which are a lot simpler than it sounds. Okay, so screen, space, shadows. Okay, so what was it on? 16 for shadows. Okay, so on our outline, I kind of combined this. So I'll just say depth, normals, and SSAO. Okay, so depth only, depth, normals, depth, pre-pass. Okay, so I actually do fog next. I forgot about that. Fog is also pretty simple. So in order to support that, I've got to add another keyword. This one's kind of special. Unity has like a special pragma set out just for fog. Let's see, where was that? It's right before the debug. And then in the forward pass, so like we've already implemented vertex lighting, and traditionally the fog factor is also stored in the same interpolator. We can go ahead and switch that out. It's not like it's much more complicated. Oh. And then the other weird thing is that for some reason URP doesn't add the mix fog into their fragment function, so you've got to like call it afterwards. I don't really know why. I guess they just have never done it, so they didn't want to change. Okay, so float 4 color equals that, and then color equals this. So okay, so that should be all I have to do. So it's really easy to test fog. Just turn it on. I think it's in the environment. So I gotta turn on fog. And if we okay, let's move this out so I can have both windows open. Guess that works. So if we move the camera away. Not quite. Oh, there we go. So I can just increase the density. I think the reason I didn't notice it is because everything's kind of gray already, but you can see as you move it away, everything tends towards the fog color, and then I can change it to red or whatever, which makes it more obvious. And there's a bunch of different modes. Basically just make it fade out at different ranges. The linear is kind of nice, so it lets you provide like a specific distance at which everything should be fully fog colored. Okay. But anyway, you can see that's all we have to do. Let's test it. And 2021.2. Why don't I stream to YouTube? YouTube's easier to climb than Twitch because Twitch has no algorithms and it only shows those who have the most viewers. I've thought of that, and I've actually, well now especially since YouTube isn't really my job anymore, I've thought about switching to streaming to YouTube. The reason I used to not is because I kind of wanted to diversify and not be like, you know, chained only to YouTube. But I probably would get more viewership there just because that's where my audience is, so I don't know. Right now I am a Twitch affiliate, which means I can't multi-stream. But I could always cancel it. I guess it is something to think about, for sure. Okay, there we go. Don't know why it took so long to compile there. Let's move this over. Okay, so that works, and exponential works, and linear. What was that? Oh, I've still got screen space shadows on, I guess. Let's turn that off. Okay. Oh, I was in play mode the whole time. Oh well, not like it really matters. Okay. Don't need the fog on. Okay. Let's write something about fog real quick. Okay, so fog is a cool feature that's really good for wide open areas. This allows, or let's see, it allows, or it makes your objects fade to a specific color depending on their distance from the camera. This way you can have them slowly fade to a skybox color before hiding them for performance. Okay, to support fog, first add a special shader feature to your forward lit pass. Unity provides this as shorthand for the various fog keywords. Okay, and then in your forward lit pass, we need to calculate a fog coordinate, which is similar to distance from the camera. This is traditionally stored in the, or stored with vertex lighting packed together into a single interpolator field. Okay, so calculate it in the vertex function and store it with vertex lighting. Then in the fragment function, store both values in the lighting data structure. The PBR algorithm does not automatically calculate or implement fog. However, we can easily add it by calling this URP function. It doesn't care about alpha, so only set the RGB values of the final color with the fog result. Okay, so back in Unity, test things out by turning on fog in the lighting environment window. There are several. Okay. I'm gonna make me draw an arrow. There are several different fog modes to choose from, and they're all supported. You can even change the color objects fade out to. Alright, so that's all for fog. That was really simple. Alright, let's save the scenes, just make sure I don't lose anything. Okay, so this is just 17.1 fog. Okay. All right. So next up. Okay, so now it's time for decals. Okay, so I guess I was gonna explain screen space here, but I actually have already done it. Okay, so adding decal support is actually really easy. First, we just need to add a bunch of keywords. And then we need to add apply decal to the surface area. Or surface data. Is that the right place to put it? Yeah. And that's all we have to do. Now, I mean, technically decals can affect normals. So I guess it could kind of affect the depth normal pass, but they don't apply decals here, just the detail texture. So, oh yeah, I don't think I'll do it either. Because probably decals aren't available at this point in the render pipeline. Okay, and yeah, once again, decals are not available in this version of Unity. So we've got to go to 2021.2 to see. Okay, so first I need to add a decal renderer feature. Okay, and then there's two different modes. I think it kind of defaults to the debuffer mode, but let's actually see. Okay, so we have to add... Oh, here we go. Okay. Kind of funny. Not even Unity changes the shader graph thing for decal shaders, but alright. We'll do just a rainbow decal. Okay, so why does the debuffer mode not work? Okay, I've got the compiles here. I'm pretty sure I got it working here. So yeah, I have the decal projector. Oh, but there's nothing on there. Okay, then... Alright, I apologize if you can hear that really loud car. Okay, so I have the debuffer mode does work. And you can see it makes a big difference. Because screen space, you can see the flat faces on the sphere. but when I change it to debuffer mode, it actually matches the normal of the object. And then, let's see. Okay, I don't have a normal map here, but okay, so I must be forgetting something. Why is this mode not enabled? Do I have to apply some hidden feature or something? Okay, let's see. So URP decals. So it requires depth normals, which we have already. Huh. Okay, I thought this would be a super simple thing. Am I? Oh. Okay, it doesn't show in the scene, I guess? But it's right here. Okay, this is switching like what? So you can have decals which have only albedo, or you can have them with albedo and normal, or you can have them with albedo, normal, metallic, ambient occlusion, and smoothness. Alright, I don't know why it doesn't show in the editor. I'm gonna just restart this scene, or this game. Huh. Okay, maybe it's because I don't have instancing on. Because, yeah, I don't support instancing yet, so. So here it's drawing the decal buffer. And so this one is color, normal, and then metallic ambient occlusion, which for whatever reason the default decal shader doesn't even support. I guess we could modify it ourselves, but oh yeah, this isn't really a decal tutorial, so I'm not worried about it too much. Seems to have something to do with the decal buffer not rendering. That's kind of funny. So if I set the normal blend to 1, I would have thought it would make it just use whatever our normal map is, but apparently not. And again, this center object is just using a lit shader, right? So it's not like it's just my material that's doing it. I almost think that the normal map is in like the wrong space or something. Let's see. Can I not? I was going to try to edit the decal shader graph myself, but it doesn't look like it's in there. Okay. Is this supposed to be how it is? Because it doesn't sample the normal map as a normal map. Let's see. Well, let me keep this. Oh no. Yeah, I was gonna say, usually you can't edit. Yeah, so if I close this, it is gonna be back to how it was because Unity doesn't let you edit stuff that's in packages. Yeah, so I'm not sure. And this is a special shader because it is actually like outputting to multiple decal buffers, so I don't know if I can just like replace it. Where is there? Maybe I can. Let's see. Let's just try it. I guess, you know, I shouldn't really be doing this in this project. I should be doing it in my research project. Okay. Although it seems to work fine here, but is the normal still weird, I guess? still a little strange. It's not quite as strange as before. I mean, I feel like that's not how it should work, because we just want to project the normal like onto, like just replace the normal map of my material with whatever the normal map on the decal is, so it would just be slightly curved instead of, I don't know. I mean, that doesn't look right to me. Alright, well, let's try and add our own decal shader and see if that fixes the issue. Oh, I can do it. Okay, so my decal. Oh, you can even just have a decal material. Okay. Yeah, so we want color. Normal. Oh. And then MAO smoothness. And I guess we might as well have tints and normal strength and metallicity, or I guess we'll just do metallic, occlusion, and oops. Smoothness. Okay, so these will all be sliders from 0 to 1. Mouse alpha. Oh, I see. So they let you have like different alpha values for like the blending. Okay. Okay, so I guess I should have different floats. So color, blend. Well, why don't we just have a blend for all of them? So this will just be a blend. I guess I don't have to spend a ton of time on this. I'm just kind of curious because it seems like the regular decal shader is a little buggy. Okay, so then I want to multiply alpha with the blend. Go there. Okay, so then we'll also do this for the normal map. I guess we can. Oh yeah, and I need to multiply. And I should actually take the alpha from this to to use instead of the alpha from the sample. What? Where'd the other values go? Oh, okay, so we want... Oh, you can also have emission. Okay, so normal strength. Okay, so I think that was the bug in the default one, because they don't set the normal map to be normal type, so it doesn't what I'm trying to say. So yeah, it's like the encoding is messed up. At least I think that's what's wrong anyway. Because this is also the normal alpha and the metallic ambient occlusion alpha. Okay, so one more. Okay, so this one I need to multiply with each of my little properties here. So red is metallic. And then we've got ambient occlusion, which is green. Okay, I know this isn't the cleanest, but we'll deal with that for now. And smoothness, alpha. Okay. I should set the default for this to be white and full alpha. This is gonna like override it. Okay, well, there you could definitely make this better, because I kind of wanted to just only project normal vector. I mean, I guess I could do that. Because I only have blend. Because for the entire thing, but if I wanted to have only normal, then you could blend with just the normal. But it's fine. Let's just test to see how this works. Okay, so this is my decal shader, the one that the projector is using, right? Yeah. Okay, so if I turn the normal strength up, okay, it does apply it and it's not weird. So yeah, I think that was the problem. It's kind of annoying. Well, is it? I just don't know. I feel like it shouldn't work like this, because the decal is like making the normal vector point differently. Let me see. I think with the frame debugger I can get the actual normal vectors, or the rendering debugger. Okay, yeah, so you can see there's like a... Okay, I guess this is just how decals work. Because probably applying the normal from the projector space. I thought that it would like kind of like... Okay, yeah. I guess this is how it works. Because I still think that the shader graph might have been bugged, but it's like applying the normal in world space to this material, not like applying a tangent space normal. I mean, I guess if you wanted to do that, you could edit your shader to read the decal buffers as tangent space normals, and then you could apply that to your material, which is kind of how I thought it would work, but that's not how URP does it. Which I guess makes sense. We can probably see the actual code. Let's see. So in decals. So I need to find. Okay, so apply decal. So we have our normal. Let's see, how does it overwrite it? Okay, so always test the normal as we can have a decompression artifact. So if the decal normal is less than 1, then we overwrite. Well, this is kind of LARP. Is it LARPing? So it's our normal, and then we take our normal times the blend factor. Then we add in the decals normal. So yeah, it says blending in world space, not tangent space, which, I mean, I guess it's probably, this is however you want to do it. Okay, but anyway, that was kind of a tangent, but I just wanted to check that out. But so now we know. Decals are in world space, so you will kind of get this hard line there if you use normals, but you can always just turn off the normal value of a decal, or the normal blend of a decal. Okay, but I guess I still don't know why it flickers and doesn't show in the scene view in this, so I guess I should check that out, but yeah, it's already been streaming for 3 hours, so that's usually when I cut it off. I need to go get some lunch, but probably by the next stream I'll have already finished up the rest of the second video. So yeah, we just have to figure out that bug with the decals, and then we have stereo eye, which is probably better that I don't test that on stream because I'm gonna have to test it with my VR headset, which would be a little awkward. But so I bet next weekend we'll start on custom lighting, which is, I know a lot of people have requested this. And basically we'll look at how you can read light data in your own shader and re-implement a lot of the stuff that the PBR algorithm does for us. Yeah, then we'll look at some other things you could add to your shader. I think I'll probably just do time and vertex animation, maybe some more advanced HLSL stuff. I don't think we'll really get into all of this because probably they should go in their own tutorial, but anyway, thanks everybody for coming by, viewing and chatting. I really do appreciate it. I'll be back for sure next weekend, and we'll continue with the shader. If you enjoyed the stream and you'd like to connect with me on social media, I'll put some links in the chat. I do have a YouTube channel where I post all of my Unity tutorials, as well as stream VODs if you'd like to catch up. But I hope you have a great rest of your weekend, and I guess a great week, and I'll see you Saturday. All right, bye-bye.